My name is Richard Furrow, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
Well, I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the Glowcloud team.
Okay, welcome back. We are here for day 5 of the Google Professional Cloud Architect Bootcamp to prepare you for the Google Professional Cloud Architect certification and Professional Cloud Architect exam. My name is Mike Gibbs. I'm one of your instructors throughout this program. I am joined here by Leo Paredes from our team. Leo is a dedicated engineer with more than 2 decades of experience. I'm obviously an architect who's been an architect for about 25 years, well, a little more than that, but I'm just going to keep it at 25 years. It doesn't sound so bad. So we're here today for another day in the Google Professional Cloud Architect Bootcamp. If you just joined us now, or just heard about this now, or just found out, don't worry. You can go back and watch day 1, day 2, day 3, and day 4. And we'll be training all of next week for this Google Professional Cloud Architect exam as well. So you can watch them all over the weekend. Maybe invite a couple of friends to watch the videos with you. And then we'll be back next week. Couple of things to talk about, and then I'll give you the overview of the day. And then Leo's going to talk a little bit because Leo's got a big role today. But I wanted to let you know that we have a guide on how to help you pass the exam. My team wrote it. It's about 550 pages. It's probably almost as thick as this book that I actually really like from Cybex. That I actually thought was great to prepare the exam. Yes, it's about 200 pages. Ours is about 500. So hopefully it'll give you a lot of guidance. Again, I do like that Cybex book and I highly recommend it. I'm not an affiliate. I don't get paid for it. I just like the book. I think it's a great book. But to show you, we put a lot into this. So go download the study guide, or sign up, and it'll be emailed to you. And go out there and really learn something from this. So, that's good. I'll let you know that every Thursday we have an architect webinar, how to become an architect. My team will drop a link to that. We'll go over what we do as cloud architects, solutions architects, AI architects, executive architects, any other kind of architect you want, and we'll answer any questions. And I also want to let you know that about once a week I come online to answer career questions. So keep track of us, subscribe, hit the bell to be notified of new things. When I come online and you've got questions to ask, I'll be here to answer them for you. So today we have a lot of labs. We're going to start out. We've got a lot of labs, like one big one and a couple of small ones. So, and then we also have some lectures today, but it's going to be a big, heavy lab day, which I think a lot of people are going to have some fun with. So, Leo, could you tell me what labs you have going on today?
Sure, Mike. The first lab for today is a continuation of yesterday's topic, the networking. The lab is about load balancers, how to use load balancer to direct traffic to virtual machines in different regions. Yesterday's lab was about directing traffic to virtual machines in the same region. Today's lab will be multi-region load balancer.
And that's great. So thank you for that, Leo. I'm going to be talking about compute, like things like virtual machines and containers. We're going to have a little fun with that. You'll get to see some of these things in action. So let me know that you're awake, you're alert, and you're oriented. Give me a hashtag Google Professional Cloud Architect or something to that so that I know you're awake. And as soon as I start seeing that and I know you're awake, let me know. I also like to know where you're at today. Where are you at in the world? I know I'm in Port St. Lucie, Florida. I know that Leo's in Sao Paulo. I know Chris is behind the scenes in St. Petersburg. But where are you? St. Petersburg, Florida, as opposed to St. Petersburg in Russia. So, but that's where he's at today. So let me know where you're at. I know some of you have got to be in Europe. I know a lot of you have got to be in Africa. I know some of you have got to be in the Middle East, and some of you are Asia or even Australia or other parts of the world. So let us know, South America or North America, like us. And would love to see that in the chat box. So let me know where you're from. And give me that Google Professional Cloud Architect. I heard it from Adrian. I know Adrian's awake, alert, and oriented. I see it from Ben. Gives me a little idea of the amount of latency between the time I speak and the time you guys see stuff as well, because there is a delay on this. So Phoenix, Arizona. Oh, that's a nice dry place. Jersey City. I actually worked in Jersey City for about 1.5 years. It was really hard to get to because it was either take like the PATH train and all these other trains or drive up, which is what I did every day. Emmanuel in Germany, fantastic. I absolutely love that. We've got someone in India. I absolutely love that. Thank you for sharing some of your geography. I love knowing that we have people everywhere. And because we're all the same. And it's nice to actually get everybody together for a common goal. At least that's something that I've always dreamed about is get everybody together, train people for the better future, and all have better lives. So, Chris, I think we know where people are from. I think they're awake, alert, and oriented. Let's start with the content.
Hello. In this lab, I will demonstrate how to create or set up a multi-region load balancer. In the previous lab, I used this document to set up a regional external application load balancer with virtual machine instance group backends. From the left side menu, I will scroll down to open the Explore Tutorials topic. Then I will click the first item, Request Routing to a Multi-Region External HTTPS Load Balancer. I will use HTTP and not HTTPS in this demonstration. Here under the Overview section, it reads, "This guide provides instructions for creating a load balancer that directs traffic based on the path in the request URL and balances traffic across multiple regions. You create 8 total compute engine instances in the US in zone US Central 1B and Europe in zone EU West 1B regions. You will then create a load balancer that routes traffic to these instances. And here is the diagram for this system. I will right-click and open the diagram in a new tab. And the functionality of this load balancing is basically to receive the requests from the internet. A forwarding rule will forward the request to the target proxy. The proxy will pass the request to the URL map, which has the responsibility to directing the URLs that contain the /video in it to the corresponding backend service. The requests that don't contain /video in them, they will be sent to another backend service. Each backend service is responsible to direct traffic to 2 different regions or 2 different groups of virtual machines, one in the US in region US Central 1, another one in Europe in region Europe West 1B. The same is valid for both backend services because the pool of virtual machines, they are for different responsibilities, but they are located in the same region. The same US Central 1 region will have a pool of virtual machines for anything except video, and also a pool of virtual machines for responding for video requests. The same is valid for the other region. I will not use Europe instead of having this backend directing the requests for a group of virtual machines in Europe. I will configure a subnet in South America. I will continue to scroll down. And there are some permissions considerations here. If you created this account to learn the Google Cloud Platform, your user has every permission needed to do this lab. If you are an employee in an organization, you will probably need specific permissions to do these tasks. I will keep scrolling down. Here is the setup part. And there is an optional suggestion to create a new project. This makes the cleanup easier because when you delete a project, you delete all the requests or all the resources inside it. But if you want to reuse the project later, you should do the cleanup, deleting the individual resources used in this demonstration. Here is the configuring a network and subnets section with the names of the subnets, the respective IP addresses to be used, and the regions where the subnets will exist. I will replace the EU subnet with a South America subnet, but using the same IP address range. Here are the steps to create the custom mode VPC, and I will go to the console to execute those steps. From the top left side menu, I will select VPC network and then VPC networks. I will click Create VPC Network. And then here, the name of the network I will follow and use all suggestions from the documentation. It should be LB network. The subnet creation mode will be custom. And the new subnet, the first one will be called US subnet. And the region will be US Central. US Central 1. I will only use IPv4 in this demonstration. The IPv4 range for this subnet should be 10.1.10.0/24. And I click Done to create this subnet or to finish the configuration of this subnet. I will click Add Subnet to add the second subnet for this project, but I will not call this EU subnet, but I will replace the EU with South M as in South America, and the region will be South America East 1. The IPv4 range is the same suggested for the EU subnet in the documentation 10.1.11.0/24. And click Done. Now I have the two subnets set to be created, and here I have the option to set or select some firewall rules. On the bottom, we have two rules that cannot be unselected. They are created by default, and the first one is to deny all incoming traffic, all ingress traffic into the VPC with a very low priority or the lowest possible priority. And the other rule is to allow all egress or all traffic going outside the network. So no traffic by default is allowed in. Any and every traffic by default is allowed out. Any rule that you create will, with a different priority, will override the default deny all ingress traffic rule. For this demonstration, I will need to create a rule to allow HTTP inside the network. For now, I will select the ICMP and SSH rules just for simplicity. The dynamic routing mode, I will select global since I'm using more than one region, and then I will click Create to create this VPC network. While the network is being created, I will go to the firewall page here on the left. and it shows the ICMP. This VPC network already has a default VPC. Let's go back to the VPC network, VPCs, and the default network already exists. For this reason, there are some rules here in the firewall rules that are for the default network. These are the only rules for the load balancer network VPC just created. And I need to create a new firewall rule. So I will click Create Firewall Rule, enter the name of the firewall rule as firewall allow health check in proxy. If I haven't done, I will not create the first firewall rule on the document, which is for creating the SSH, allow SSH, because I already selected the option from the firewalls page. I'm creating this new rule here. And here I will select the network is not the default one, is the load balancer network, and look at the priority. Every time you start creating new rule, the priority is set to 1000. This rule will override the default rule to deny all incoming traffic. The direction of traffic for this rule is ingress, and the action is to allow the traffic. And here I will specify or restrict. This rule only applies to the virtual machines that has the following target or network tag: allow health check. Only the virtual machines that contain this network tag will be able to receive the traffic allowed by this rule. And the source IP address range, as per the document, is 130.211.0.0/22. I will tab to allow me to create the next one, 35.191.0.0/16. So these are the IP address ranges from the health checks. The incoming requests will not go straight to the virtual machines. The incoming requests will be received in the HTTP proxy, and the health check will verify if the virtual machines are healthy, and then the traffic will be sent from the proxy to the virtual machines based on the response for the health check. That's why only the health check IP address ranges are allowed as source of the requests that are coming to the virtual machines. Here, from protocols and ports, I will select TCP and the port A and click Create. Now I have the firewall rule allowing HTTP inside this virtual private cloud. Let's go back to the document and see the next step is to create instances. The virtual machines in this lab will be created based on instance templates. We will create the templates and we will create manage instance groups which use the templates to create the virtual machines. But the first step is to create the instance template. So I will switch, or I will go to the Compute Engine Instance Templates page, click Create Instance Template, name as per the document, US, or better, video, US template. And it will be created in the region US Central 1. I will keep most of the defaults already selected for creating the instances, but I will change the boot disk because I will use a custom image I have. After selecting the image, I click select, and then I will open the advanced options for the networking. I will enter the network tag for the virtual machines that will be created with this template, and the network tag is allow health check. Since I created the firewall rule for SSH, I will not create the network tag for the SSH rule. The network interface was created in the default VPC. I will delete that one. Click add a network interface, select the load balancer network, and select the subnet in the US for creating this network interface. I will click done. And from the manage part, I will scroll down to the automation where I will enter the startup script. The document suggests a startup script here. I will not use this exact startup script, but I will use one that does a similar job. I will copy the startup script from my external source and enter it here. And I will explain this startup script. Here, it informs that this is a bash script. The first command will query the virtual machine metadata and bring the name of the virtual machine and store that name in a variable named VM_name. The next command will query the metadata of the virtual machine, bringing the external IP address of this virtual machine and storing this value inside the external _IP variable. These two variables will be used later in the code. I will explain them. After querying the metadata, the script creates a directory because since I'm using an image that already has Apache web server installed, Apache's default path for the resources the web server will send to the user as the response for the requests, the default path is /var/www/html. Since these virtual machines created with this instance are for responding for video requests, I am creating, or the script will create a video subdirectory inside the default path, and the resources from this directory will be sent as response for the user requests. After creating that directory, the next command removes the original index.html created in the default path of Apache web server, and another one is immediately created, but with the following content. Here is the HTML code. Inside the head of the HTML file, there is a title which says My Apache Web Server page. This will be shown on the tab in the browser when this index.html is sent back to the user as a response for the request. Under the head of the HTML file, we have a script section. This script is basically generating a random color for the background of the web page every time this index.html is sent to the user. This means each refresh on the browser when accessing this virtual machine, each refresh will generate a new random color for the background of the page. Now, in the body of the HTML file, there are 3 lines. The first one is the welcome to my custom page. This will be shown on the page on the browser. The second line shows this is virtual machine, and then it shows the content of the VM_name variable, which contains the name of the virtual machine. The third line shows external IP address, and then it shows the value of the external IP address for each virtual machine that is sending the index.html file back to the requests, to the user request. The last command in the startup script is to copy, since this HTML file was created in the default path for Apache Web Server. The last command will copy the index.html from the default path and paste it into the new path with /video. So the index.html file will exist inside the video subdirectory because some of the virtual machines will respond to requests containing /video in the URL. After setting up the startup script, I can click Create to create the instance template. The next template I will create should be for video as per documentation. The next one should be for video EU template. But as I am not using Europe, I will use South America. This will be called Video South America template. Video South America template. The region will be South America, East 1. Again, I will accept most defaults, but change the boot disk to the custom image. Click Select. Open the advanced options. From networking, create the Allow Health Check. Network tag. Then delete the default network interface and add a new network interface in the load balancer VPC and select the South America subnet. Click Done. Then from the management, scroll down and paste the startup script and click Create to create this video template for South America. Now I need to create the www.us template. Create instance template, www.us template, US Central 1, change the boot disk to the custom image, click Select, open the advanced options from networking, allow health check, network tag, delete the default network interface, add a new one in the load balancer network, South US Central subnet. Just to make sure, yes, I selected the US Central. Click Done, and from the management, paste the startup script and click Create. And the last one will be the www Europe template, which I will use www South America template. The region is South America East 1. change the boot disk for the custom image. Open the advanced options from networking, create network tag, allow, health check, delete the default network interface, create a new one in the correct VPC and region. Click Done. From the management, paste the startup script and click Create. Now I should have the 4 instance templates. I have Video South America, Video US, and www South America. For some reason, the www US doesn't show, or I skipped that step. Let's create the www US template. US Central 1. Change. Use custom image. Open the advanced options. Create the network tag. Allow. Health check. Delete the default interface, add the new interface in the load balancer network, US subnet, click Done. Open the management into the startup script and create. Now I should have the 4 instance templates. And the next step is to add a name port to the instance group. Oh, better, before I add a name port, I need to create the manage instance groups. I'll go to the instance groups page here on the left side menu. Click Create Instance Group. Make sure you select the stateless Manage Instance Group here from the left, and then you enter the name of the instance group as per the document. Instance group, Video US. In the instance template is the Video US template. The location as per the documentation should be single zone. In the region will be US Central 1B. For the autoscaling, I will select off as per recommendation of the documentation, and the maximum number of instances will be 2. Then I will click Create. And I will create another instance group. Instance group, Video South America. The instance template will be Video South America. The location will be South America East, South America 1B. Autoscaling set to off, and maximum number of instances 2. Click Create. Now creating the www manage instance groups. The first one will be instance group www US, based on the instance template www US template. Location US Central 1, zone US Central 1B. Autoscaling turn to off, maximum number of instances 2, and then click create. Now to create the last instance group, that is www South America. Instance group www South America. Instance template www South America template. Location South America East 1, South America East 1B. Autoscaling set to off, maximum number of instances set to 2, and click create. There are some warnings on the instance groups. They are about the autoscaling being turned off. But I see the instance groups were created with one instance. I will click each one and force the number of instances to be 2. I will do this for each manage instance group to make them have 2 instances each. Now, all 4 managed instance groups should have 2 virtual machines each. We only need one more to have 2 virtual machines. Now, the next step is to add the named port to the instance groups. So for each instance group, I will click Edit and then scroll down to the port mapping, click Add Port and enter HTTP and the port AE. Click Save and go to the next instance group. Now, all 4 managed instance groups have the port mapping set to HTTP with port 80. The next step is to reserve the external IP address. I will go to the VPC network IP addresses page and click Reserve external static IP address. The name for this IP address will be load balancer IPv4-1. Keep the network service tier as premium. The IP version is IP version 4 and the type is global. Click reserve. We can see the external IP address with a warning, and this warning is about not being used. The static IP addresses reserved, they cost more if they are not in use than when they are in use. The next step in the documentation is to configure the load balancing resources. So I need to go to the load balancing page. From the top left menu, I select Network Services, Load Balancing, and then I click Create Load Balancer. The type of load balancer will be Application Load Balancer. Click Next. The public facing or internal should be selected as public facing and click Next. The global or single region deployment should be best for global workloads. Click Next. And the load balancer generation should be set to Classic Application Load Balancer. And click Next. And then click Configure. Here, we enter the name of the load balancer, which should be WebMap. And then the documentation instructs to configure the backend services. So let's select backend configuration here, the center, and then click the backend services and backend sub buckets and click create a backend service. The name of the backend service should be web backend service. The backend type should be instance group, the protocol HTTP. The new backend instance group selected will be should agree with the backend service. Since this is a web backend service, I will select the web instance group. The balancing mode should be utilization, and then I click done. And I will add another backend. Since this backend service is for web, I will select the other web instance group, which is the www South America instance group. So now we have, for this web backend service, we have two backends, one in the US and another one in South America. I will unselect the Enable Cloud CVM here, and for the health check, I will click Create a Health Check. The name of the health check will be HTTP basic check www. The protocol will be HTTP port 80, and then I can click Create. And then I click Create. We now have the web backend service. Now I will click Create a backend service again to create the video backend service. The backends now will be the video US, and click Add the backend for selecting the video South America. So for the video backend service, we have two backends, one in the US and another one in South America. Again, I will unselect Enable Cloud CDN, and from Health Checks, I will click Create a new health check. And the name is HTTP Basic Check Video. The protocol is HTTP, and then click Create. And then click Create again. And there is some issue. Let's remove some letters here and click Create. Now we have the two backend services, one for web, one for video. I can click OK. Click Hosts and Path. Here for all unmatched path, host and path, when the web backend service is already selected. For the video backend service, I will select the host as in asterisk or star, and the paths will be /video, hit tab, and then /video /star. According to the documentation, now I should configure the front end. And there is some IPv4 configuration and also some certificate. I will set the IPv4, but I will not use certificates in this lab. And then from the front end, I will delete this ephemeral existing one, and I'll click Add Front-End IP and Ports, and I will use the name HTTP content rule. The protocol will be HTTP, and IP version IPv4, and the IP address I will select now the static IP address we created before, and then click Done, and now I can click Create, and with this change the load balancer is ready. The next step in the documentation is to configure IPv6. I will not use IPv6 for simplicity. And the next step would be to connect the domain to a load balancer. I will not use a domain in this demonstration as well. I will skip to the sending traffic to the instances. Basically, is to test the functionality of the load balancer. For sending traffic to the instances, I will switch to the Compute Engine VM instances page. And I will test one external IP address from an instance, or I will test two. Let's say one for South America, one for US. And the requests sent in the browser tabs, they are not receiving responses from the virtual machines or from the web server. I will now get the external IP address from the VPC network IP addresses. I will copy this static IP address and paste it in a new tab. and hit enter. And at least it's different. The external IP addresses from the virtual machines, they don't seem to respond. The browser keeps trying, but no response is received. For the external reserved IP address, there is one answer: the site can't be reached. I will keep refreshing this tab with the external reserved IP address up to the point it becomes responsive. While the servers are not responsive, let's go to the network service load balancing. Open the configurations of the load balancer and check the monitoring. Let's go back and select backends. And now, for instance, the video backend service, we can check the healthy that 2 of 2 virtual machines in South America are healthy. 2 of 2 virtual machines in the US are also healthy for the video backend. Let's go to the web backend and verify if the virtual machines are also healthy, and all 4 of them are healthy. Let's try again to refresh the browser tab with the external IP address for the load balancer. After some time, the virtual machines start to respond to the requests I sent for the external IP address allocated to the load balancer. And here I have the response from a virtual machine named instance group www South America with the IPv4 ending on 44. Let's see if we can reach the other virtual machine in the same instance group. And we have the virtual machine number v21 still for the www managed instance group, and all of them in South America. So we have the virtual machines ending on 21 and 44 for the www managed instance group. And now I will add the /video to the request URL and see if virtual machines from the other managed instance group will respond to this request. And here, the name of the virtual machine is instance group video South America with IP address ending on 52, and the other one will end on 217, still with video from South America. So I have already reached the 2 different instance groups, one for video and the other one for www in South America. Now I will connect a VPN to obtain an IP address in the United States, and I expect to receive responses from the virtual machines from the US instance groups. The first one should be www. I will not add the video part yet. I will hit refresh now that I have the IP address located in the US. And let's see if the requests are responded by the www US virtual machines. And here we have one with the IP address ending in 58, and the other one ending in 68. Both for www. Let's add the /video to the request and see if the video US virtual machines respond to the requests. And here We have one from South America, probably is about the cache that was in the browser. Let me refresh the page. And now we have a virtual machine from the instance group video US responding to my video request. IP address 236. Let's see the other virtual machine is the virtual machine ending with 43 from the instance group video US. With this, I demonstrated that all 8 virtual machines are responding to requests sent by the browsers. We have 2 different backends, one for video and another one for anything but video. And we have 4 managed instance groups, 2 managed instance groups in the US, one for video and one for www, and 2 managed instance groups in South America, one for video and one for www. And the tests showed all 8 virtual machines responding to the requests. If I try to reach the virtual machines directly using their external IP addresses, there is no response. In this lab, I demonstrated how to create the instance groups, the manage instance groups, how to reserve the external IP address, and how to configure the multi-region load balancer. I will now demonstrate how to do the cleanup without deleting the whole project. I will close these tabs I'm not using anymore, and I'll go back to the console, and if I follow the documentation, the cleaning up starts with, if I'm not deleting the whole project, start with deleting the load balancer. So I will go back here to the load balancer. I select the load balancers, and then I select the name of the load balancer here and click delete. It offers to delete all backend and health checks as well. I select all of them to be deleted with the load balancer. The next step will be to delete the instance groups. I will go to the compute engine page, instance groups. And let me see if I can select all 4 instance groups to hit delete. I can't. So I will select, not even selecting one by one, I will click the name of each managed instance group and then hit delete group from inside the group. I need to type delete and click delete to confirm I want to delete the instance group. I will do this for each one of the 4 instance groups to delete them. The next step in the documentation is to release the external IP address. I will go to the VPC network IP addresses page, select the static IP address, and then click Release Static Address, and click Release to confirm I want to release that IP address. Then there is the deleting firewall rules part. I will go to the firewall here on the left, and I can delete the firewall rules created for the load balancer network. Then it suggests to delete the virtual machine instances, but this was done when deleting the manage instance groups. So the virtual machine instances page should show the virtual machines already being deleted. For some reason, 2 virtual machines were not deleted automatically by deleting the manage instance groups, and I don't have the option to delete them. So I assume the instance groups are still not deleted. We are still deleting some instance groups. After some time, the managed instance group is deleted, and so are the virtual machines. Now I can go to the VPC networks, click the name of the VPC, and then select Delete VPC Network. I need to enter the name of the VPC here on this field to confirm I want to delete the VPC. After some time, the VPC network is deleted. In this lab, I demonstrated how to set up a multi-region load balancer, and I demonstrated at the end how to clean up and delete all resources used in this demonstration. Thank you for watching, and see you in the next lab.
Welcome back, everyone. So I hope everybody enjoyed Leo's lab. We got fairly technical on that. Leo, while we wait to see if there's any other questions, and there's a question, really good question from In Production that I'm probably going to spend 10 or 15 minutes on, because it's a real question. It's a deep question, and I have to give them the test answer, but I want everybody to know the real answer. Do you want to tell everybody real quick what the next labs are about?
Sure, Mike. We will have labs on creating the virtual machines and how to use the startup scripts on virtual machines as well.
Sounds great. Okay, so Chris, why don't we bring in the first question? If you have some questions, ask them. And so I know that you're here and you're awake and you're alert and oriented. Maybe give me a hashtag Google Professional Cloud Architect or something like that. So in production, Mike or Leo, could you discuss the machines, type, series, codes, platforms you see? So here's what I'm going to discuss. First, I'm going to answer your question in the most professional certification approach, and then I'm going to tell you the reality that you actually need to know. But for the professional approach, I'm going to point you to this Google page here, and I'll pop the link in the chat box. And this Google page is updated by the people at Google Marketing, and they basically give you all the names that they actually call their systems as they use them. So if we walk through this, you can see as we drive down, they'll have their machine families, and you can view what they viewed as their first and second generation servers. Now, these will tell you they're Intel. You're going to have to research the processors on what these actually are, and I'll actually talk about what that is in a minute. But they'll use the way they categorize these technologies. So For example, you'll be able to see which ones have local SSD that you could use versus something that would just be block storage somewhere else. You can tend to create your own. And then they're going to make recommendations on marketing like this type of C4, this is good for a database or a high volume web traffic or an analytics traffic. So they're going to tell you what they actually recommend, but these are marketing terms. For example, AWS has i3 instances. They call them general purpose compute. The i3 instances, I use them in my house. I've got to tell you, I bought the servers from Amazon. They're $400 right now. You can buy these same servers. They've got dual Xeon E5 2670 V3s in it, about 128 gigs of RAM in it. I've got like 10 of them, and they're about $400 each because they're end of life. And Intel stopped selling the processors 5-6 years ago. Now to Amazon, they're still general purpose compute, and they're about $1,100 a month to use them on their system. So the key is that's every provider is going to have general purpose, what they consider to be memory optimized, what they consider to be store optimized, but none of that's going to mean anything. We're going to talk about what really is going to matter for you now. So let me get past this. And okay, I gave the answer, official answer. Go to the Google website. I pasted the website in. Now, let's talk reality. Let's talk what actually goes into compute and what goes into processor architecture. In order to see that, what I'm going to do is draw out a processor. I'm going to show you where the compute is, and I'm going to show you where the latencies and pain points are going to be in your average server. And when you see that, I think it's going to put you in a better position. And I'll walk you through a server processor and what it looks like, and I'll walk you through a video game processor and what it looks like. So you'll be able to see different hardware is going to be geared towards different things, but it's the way your applications are written and the workloads that they're going to run on matters, not what Google's marketing department calls them or Azure's marketing department calls them or anybody else's marketing department. We got to get specific here. So let's say we go into a server, and in most servers, I think I drew a motherboard for you the other day of what a server looks like, but let me walk you through the processor itself. So a processor is going to look like this, and there'll usually be two in a server, but the processor itself is the brain. It's going to do all the calculations, route the operating systems, handle all your systems calls. And even in an AI environment, the processor is going to be routing the AI destined traffic to the GPUs to do it. So if we look in a processor, the old days we used to have one CPU chip per system. But now on a chip itself, we have something called virtual processors. And what these are actual physical CPU chips themselves. And they sit on this big metal die. So depending upon how many of these you have will determine how much workload you can do if in certain applications. And I'll show you what I mean by this in a second. Let me just draw a few more cores. And this is why you're going to have to figure it out yourself. Now, this server, let's say, has 9 cores or 9 CPU chips in it. Some applications are designed that they can be split and run on all 9 of these at the same time. That is called a multi-threaded application, and multi-threaded applications work very well on a multi-threaded processor. Now, by comparison, there are some applications that can only use a single thread no matter what. So you can have a whole lot of these processors, but only one of them is doing the work and the rest are sitting idle. Now, applications that run on a single processor are going to work on the processor's frequency, how many million calculations or trillion calculations it can do for a second. And what you're going to see, that's going to be considered the clock rate of your CPU, or the frequency. I'll get to this in a minute. Now, you'll also notice that you'll have a number of cores. So your total performance ultimately will be the speed of each core times the number of cores that you have in a system. So all things being equal, and all things are not being equal, but all things being equal, if you have 4 cores and all 4 are running, if you move them to another processor that's the same kind of processor, it'll need 4 cores in the cloud, 4 cores in the data center, 4 cores on the cloud. But what if these 4 cores were from a server that's like 15 years old, and now 1 core has the performance of all of those 4 cores? Well, we're going to actually have to take into this. So we have to know exactly what our workload is. Now, on the CPU chip itself, we're going to have something else that I want you to see. And this is also going to affect the CPU's performance. We're going to have some cache RAM over here. And the key with this is I want you to see how fast it is. So the cache is directly on this chip, which means if we store anything in here, it is going to be brutally fast. Because imagine this happens, and this is typically what happens in a server. Stuff comes in, gets run. Stuff comes in, gets run. But sometimes a lot of the stuff could sit here. And if you could fill this and wait, then 100% of this capacity would be used. You may notice you use a queue in a database for a very similar reason, but that's one of the reasons you're here. Because you've got your system DRAM, which is going to sit on the motherboard. And this isn't a normal x86 type architecture. It's a little different for RISC processors. But what you can see is if the information's in DRAM, it then needs to leave from DRAM across the motherboard to get into the CPU. So the more cache you have and the more stuff you can load in this cache, the more work it can do. So what we're typically looking at is the frequency plus the clock rate. And by that, you'll be able to determine what you need. Your application developer should know, what every time that thread runs, how many CPU cycles it's going to hit. And if not, you're going to have to test it. You're going to have to test it anyway. And then the slow storage on the servers would obviously be the storage, the hard storage, which is why, and just in case you were curious, I'll just call this a hard drive. If a CPU is running low, if the computer is running low on memory, it will start storing memory on the hard drive called virtual memory or swap file so it doesn't run out of memory. Now, when that occurs, the hard drive is relatively slow. So the fastest we can keep it is on the cache. The second fastest we can keep it is in DRAM. And the third fastest we can keep it is on the hard drive, generally speaking. So as we tune this, we can get to better performance. So let's look at various CPUs. So I just went over to CPU Benchmark. It's a great website. You can use it to compare processors. You should notice a couple of things over here. One is, do you notice this is the ranking of the processors in order? Look who makes every last one of these top processors until you get to the Intel Xeon, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the 21st fastest processor is made by Intel. But notice the AMD owns the rest of them. And you may actually notice that a CPU that's $2,900 or $2,800 from AMD actually outperforms the Intel one that's sitting there for, I got to look pretty close, double the price. So if you're wondering why there's a lot of things in data centers that are trending AMD, right now AMD has the fastest processors. Other times in history, it's Intel, back and forth. But just keep that in the back of your mind, what's going on right now. So we have to look at the processor, but then we've got to look inside the processor and its performance capability. There's a couple of things I wanted you to notice here. This is a service processor. No, this is basically this multi-thread rating. It's taking each core and combining them all together, and that's the max performance you're going to get out of this. Look very carefully at this. This processor speed is only 2.3 gigahertz, which isn't that fast. But if you notice, it's got 192 cores. That's 192 CPU chips on that main die. That is incredible. Because in a virtualization environment, we could put, if each user was taking 4 cores, that's a whole lot of customers we could put on there. Now you may notice also threads, because what these processors can do is hyperthread, which is they can split their physical cores and logical cores. And when you get a virtual machine on the cloud, I will show you what that means in a minute. Now look at this instruction. Look at this cache over here. When you get to that level 3 cache, that is 384 megabytes. That is one of the biggest you will ever see on a chip. So this is the kind of processor where you expect it to be used all the time under extremely heavy load, like a cloud provider who has 50 customers all on a single server. We'll go back to that hyper-threaded thing in a minute, but note, see that single core rating? It's not that high. But if you look at that multi-threaded, this shows you how good this server would do. Like if it had a bunch of virtual machines on it, it is huge. Now, let's take that to the video game processor. This Intel Core Ultra 9 289-85K on paper has some incredible specs. Look at this. It's very different. Now, if we look at the specs over here, we note that that single core performance, 5097. Remember that server processor was 3210? And then when we get the multi-threaded performance, this thing is 67.8, where that other thing was 130, was actually more than that. It was 166. So that AMD processor had the ability to handle at least 2 times the workloads, maybe 3. But this computer, because video editing and video gaming is more single-threaded, video games will play better on this system, where a data center would do better on a processor like this. Now, let's talk about the difference between the real cores you get in the cloud, in the data center, versus the virtual cores you get in a cloud provider, because they're not necessarily the same. So let's go to our processor and let's create one more slide so you understand how these work, because this is how you're going to size them. So let's say this is a core. And let's say we have 192 of them in here. Now, the way this hyper-threading concept works is, if I send a thread to a single core, the core can do nothing else until the thread runs through. I'm going to say that again. So if this is a little nothing workload, and that little nothing workload tries to go here, it's going to keep it as busy if it was a big, heavy number crunch workload in certain cases. Not always. Now, this core sending that thread through might only be 5 or 10% of its capacity, or 50% of its capacity. So what this core can then do is it can virtualize itself, and it can turn it into 2 virtual cores. And it can split the load in half. So it'll take one big load. You see what this looks like? And it'll chop the load into 2 small loads if the application's written this way. And then the 2 small loads will go faster than the one big load did. That's the concept of hyper-threading. So I want you to understand this. This whole thing is these 2 halves equal this whole thing. So if you have 4 physical cores in the data center, you actually have 8 virtual cores. And if you only get 4 virtual cores on the cloud, it might not work. So you're going to have to calculate that, size that, test that, and figure that out. So just keep that in the back of your mind, because if each one of these is 50%, yeah, this is great. But what if this core is used at 100%? The last thing you need to consider in all environments, all cloud and all internet service environments is, let's say we've got 392 cores, physical cores on here. That can give us 784 logical cores. Generally speaking, not always. What an internet service provider would do, or somebody else, is maybe they'd sell 1,000 cores on the server that says 768 or more. And it works on the assumption that not every single user will be using all of their capacity at the same time, so they can oversell things. Your internet service providers do it. Everybody does it as well. So I'm not saying any cloud provider does or doesn't. Just keep that in the back of your mind. When you don't own the infrastructure, these are the things that occur. So that's why I wanted to give you the answer. The marketing answer is this. Go to that Google page, and always go to the Amazon page, and always go to the Azure page. And here's why: they're going to consistently change what their marketing terms are as new processors come out. But at the end of the day, I want you to know that you need to understand the processor and understand the sizing and understand what's going to fit, and not take any marketing numbers seriously. So I hope I answered that question. And unless any other questions came in, I'm going to let you know that we've got a lecture now for about an hour, and then we've got some labs that are going to be some fun. Leo's got about 3 more labs to do, so that's what the plan is for today. Unless somebody asks me a complicated question and it takes a good 10 or 15 minutes to answer it, but I feel like it'll be good for you to answer, and I'm happy to do that too. So let's get back to the content. If you're having a good time, give a like, subscribe to the channel, hit the bell, tell a friend, all those kind of things, and give me a hashtag, Google Professional Cloud Architect.
Now we're going to prepare you for the next section of the Google Professional Cloud Architect exam preparation. And we're going to talk about compute and containers. Now, we introduced them earlier in the training when we talked about things from a high level, and now we're diving deeper. We're still going to give you a refresher on what these are to make sure that you understand them, and then we'll talk about all the Google specifics that are related to these things. So if we look at computing and we look about it for a long period of time, when I started processors, there was one single processor on a computer, and it was in megahertz. And now we're in an environment where we put a processor chip on a computer. And as of the time we're making this, we can put 192 cores on that one single processor chip. And now we could put multiple of these chips in the same server. So it gave us massive compute capacity. And now we're at the point where private data centers, cloud computing environments, they have so much compute. And the performance of this compute is so good. It enabled us to do things that we struggled to do many years before. The technology didn't change, and honestly, it's almost identical to what it was. And in many cases in the data center, we still have more capabilities than what we get in modern cloud computing because it's emulating what we have in the data center. But understand that the power we're getting is really growing. We used to have something we used to call Moore's Law, and that was that about every 2 years, processor speed could double. But we've actually gotten beyond that in many cases, especially with GPU speed. And the point is the processors are getting so fast. The capacity is getting so fast. These servers are getting so big that it enabled us to do things. Networking has gotten so fast that we can host our virtual data center 1,000 miles away. And it's almost as good as the performance as if it was right next to us. So when I started, every company bought servers, they created their data centers, we hired our technical staffs, and we designed our own. And it worked quite fine. At some point, that became fairly expensive to operate, and organizations started to move to cloud providers. In much the same way the cloud provider's business model was, well, you don't create your own power, do you? So why would you run your own data center services too? We can do it better, faster, and cheaper than you could. And early in the beginning of cloud computing, that actually might have been true. What's changed recently is processing power has gotten so fast. And as processing power has gotten so fast, and processing power has come down in price, and storage has come down in price, understand in today's world, it's often substantially cheaper for some workloads back in the data center. Some workloads may still be cheaper in the cloud. And as a cloud architect, you're going to have to analyze that. And you're going to have to analyze what's best for your client. And each individual situation is going to be something different. So keep that in the back of your mind. One thing that cloud providing computing does is it provides a very semi-managed environment where the hardest work, the biggest heavy lifting, is done by the cloud provider. And you're just managing your infrastructure, whatever that may be, depending upon the computing model you use. And if we look ahead, cloud computing provides capacity because it's already there. It's already pre-built. So for a startup business that may not have the funding to actually, or to be able to get the financing to invest in a data center, in many cases, the cloud computing pay-as-you-go can work fairly well for startups because they don't know what their needs are and they could just rent them fairly easily. So we're going to be talking about the various offerings in compute and containers with regards to Google. And we'll talk about the offerings as they pertain to pricing and what they should or shouldn't be able to do. So that brings us into Google Compute Engine, which again is nothing more than a virtual machine. Nothing more. So in our data center, we may have a server just like this. That server will typically be running a hypervisor. It could be the free Linux hypervisor that's like KVM. It could be a VMware hypervisor. It could be a Microsoft Server hypervisor. Or it could be the cloud provider's hypervisor. And then typically speaking, that hypervisor will manage the memory. It will manage the CPU, potentially even the storage resources that are sitting in the host server. And what that actually does is it will enable multiple virtual machines to share this underlying infrastructure. So that's typically what we're dealing with a virtual machine. And the key is this is not new. It's the same as it's been forever. And this is the way Compute Engine will the same as AWS EC2, which is the same as an Azure virtual machine or an Oracle virtual machine. Now, The names of these will be different. The way these things are built out between providers might be slightly different, and the names of these will be slightly different when you use their name services. But please understand, the technology is pretty much identical. And for the most part, all data centers have been using this architecture since about 1999. That's when VMware invented the modern hypervisor, and that's when, right around the time organizations started to use server virtualization. So Google Compute Engine is an infrastructure as a service environment. It enables organizations to create a virtual machine on demand, stop that virtual machine on demand, add a virtual machine and have it auto scale out and add capacity. So this is going to be the basis of of servers inside of the cloud. Now we'll talk about managing these things and how you're going to create them. So you can create a virtual machine the way anyone always did it. And you can, we'll talk about, for example, pre-made images that you can get from the cloud and how that works. But it's all going to be exactly like we talked about. But there will be different levels of service, for example. And what I mean by different levels of service is the cloud providers typically have excess compute capacity left over. All of them do. And what they typically do is they offer it out at a lower price. AWS has spot instances. Google has, for example, preemptible instances, which is extra capacity on the cloud. And if you want to use it, you just create a bid. And as long as Amazon accepts the bid, your systems are running on those preemptible systems. And then if somebody else outbids you and say, I'm willing to pay more, your workloads are shut down. So that still might be great for batch jobs or processing things, but other times it would not work. So when we go through things and we talk about the services, understand, we're going to get involved into tenancy, like where the things are and what kind of servers, the offerings, and that's really what this section is going to be about. Understand that Google Compute Engine will be a major core element of computing on the Google Cloud because it's a virtual machine. And while there's a trend towards containers, many things run well on a virtual machine. Our most powerful applications typically run on virtual machines. Our highest security applications typically run on virtual machines because it's harder to do a hypervisor attack than it would be to escape one container to go to another, typically speaking. Not always, but typically. So we have the ability to set up our infrastructure based upon what we need. Now, when we think virtual machines, we have to think of CPU, like, for example, the capacity we need, the frequency of those CPU chips, and the number of cores, that core level performance, and the number of cores we're going to need. We typically think in the amount of DRAM we need, because obviously that's going to be required. We typically think in the amount of storage space we're going to need. We typically have to think of the kind of network performance we need. We need to think about things like, do we compute on the CPU? Or do we compute on a GPU? Do we use an x86 type architecture like an Intel or AMD? Or do we have something that's based on a RISC processor? And do the applications need to be coded that? So we always need to be thinking about this. So there's going to be a lot of these types of environments and compute systems we'll be talking about today. Now, understand that for whatever reason, they decided to call virtual machines instances on the cloud. And an instance is just a single virtual machine. And when you want to create a virtual machine or the instance, if you hear something called the instance creation process, what's going to happen is we'll have to assign a name to the virtual machine, a unique name, which is going to help you identify it later. We'll add any key value labels that we might apply to the instance to help us figure it out. We'll typically have to determine where we want this virtual machine to be, in what region, and in what data center in that region. So we're going to have to determine where we want it to be. If we put all our stuff in the same data center in the same region, and there's a problem with that data center, we lose everything. So we need to think about the implications of these decisions. And then we have to pick the type of machine. And we'll talk about that. So we also want to pick about the project. So we want to associate every virtual machine with the project that it's going to belong to. And of course, we talked about creation of projects before, but you can create and you can manage multiple instances inside of a single project. So let's talk about what the machine type might be configured. So we have to understand that we're using virtualized hardware, which means virtual memory. It means virtual CPU cores. Virtual CPU cores. And why am I highlighting that? when you have a processor, and let's say we're using the newest AMD EPYC processors that have 192 cores, that each one is effectively a CPU chip. But let's look at what can happen on the normal cores versus a virtual core. So a normal core is a single physical core, and a virtual core is almost like a half of a physical core. And I'm going to show you what I mean by that. So in a compute environment, if we have one thread or one thing that needs to happen on the CPU, it has to be run to completion before the next thing needs to be run. So if I have one thing and then something else behind it that needs to be scheduled, this has to go through before this can go through. Now, what if this single thread that's going through doesn't use 100% of this capacity, and it only takes for the one thing to go through 50%? Boom. 50%, boom. So what happens is 50% of this processor is going to be wasted. So what modern processors do, or most processors, especially server processors, enable us to do, which is where they get the vCore concept, is instead of having 100% go to this thing and it doesn't take it up, and most threads that go to the CPU don't take up 100%, it lets this processor chop itself into 2 virtual cores, and then it lets each thread be sent over a different virtual core. So in the end, the total compute capacity is not more than one of these. But because if the load isn't big enough, it'll send half the load down one and half the load down the other, which is pretty cool. But understand that if you had a single thread that were to take up 100% of this, you wouldn't be able to still handle the workloads on the second core. So a physical core is actually 2 virtual cores. So if you had something running on a bare metal server in your data center, and the server was running at 60% capacity on 8 physical cores, it doesn't mean it's still, that means that server has access to 16 virtual cores to actually do its job. So if you move it to just 8 virtual cores on the cloud, it's probably not going to be okay. Now, if it was running on an 8 virtual core in the data center, and these are the same CPU specifications with the same performance, and you're using the same number of virtual CPU cores on the cloud, then you should be okay. So make sure you consider that. It's way beyond the scope of the Google Professional Cloud Architect, but it's pretty important. So I wanted you to understand that. Now, there's going to be machine families, and here's what machine families are. The marketing departments at AWS and Azure and Google have defined things such as general purpose compute or memory optimized compute, which is compute with a lot of memory, or compute optimized. So they've come up with multiple marketing tiers. Now, these are tiers of servers that they, as a cloud provider, feel are good for general compute, or general this, or general that. All the cloud providers use that. And you could use that as information. But I encourage you to dive deeper, to actually look at what the processors actually are. Look at the single core performance of each processor. Look at the multi-core performance you're going to get on that average virtual machine. Because if you're going to take one virtual machine from the data center and you're going to move it to the cloud to another virtual machine, and you don't compare your CPUs, and you go from 8 cores into the data center on a good strong CPU to 8 cores on the cloud with a weak CPU, you may have some serious performance issues. So just keep that in the back of your mind. For the purposes of the exam, we're going to go over the flavors of what they are. So you should know them because it could be an exam question. In real life, as a cloud architect or a solutions architect, please actually look at the CPUs, the kind of CPUs and the performance of the CPUs before you make an architectural recommendation. Now, we have general purpose, which is considered to be balanced performance across various workloads. Again, not exactly specific. We have memory optimized, which are designed for memory intensive workloads like in-memory databases and caches, for example. We have compute optimized, which are typically designed for heavy-duty compute intensive type tasks. So that's typically what we're thinking about when we talk about these things. Now, how can we manage these virtual machines? Well, there's a couple ways we can do it. We can manage these things directly from the Cloud Console and use a web-based interface. We can use a command line tool to script and automate various things. We can connect to these instances via a REST API and manage instances programmatically via API calls. And of course, we can use SSH or Secure Shell, assuming we have connectivity to these virtual machines. Or with Windows, we can connect via remote desktop protocol. So those are the options, and those are going to be the options you can remote access pretty much any cloud provider's environment. Now, we're going to talk about the instance lifecycle. What is it? So a virtual machine may have lots of times or states. It may be off, it may start, it may run, it may be stopped, and you may delete it from the system. So that's considered the instance life cycle. And, managing these stages is going to really help keep cloud costs under control. Because if we keep virtual machines running that we're not using, we're going to be paying for them every minute of the day. So let's talk about what they call the marketing department at Google categorizes virtual machines. So we've got the E2 machines. And E2 machines are designed to be low cost. They're designed for day-to-day computing. Common use cases would be things like a web application, a back-end application, a small to medium-sized database, maybe some microservices, maybe some virtual desktops, maybe a good inner development environment. So general basic stuff. Now, Google has the N as in November. So November 2 Delta as N2D, and November 1 machines. And these are designed to balance price to performance. Again, what is that? It's more of a marketing term. So where are these systems geared? Well, web applications that would be a little higher performance, back-end applications that need greater performance, medium to large databases, a little bit of caching, and some media streaming. So that's your November 2 series and your November 1 series. Now, they also have the M series. M is in Mike, and I'm using the phonetic alphabet, not my name. So Mike 1 and Mike 2 machines. Now, these are designed for memory-intensive workloads. Now, these are going to give you a lot of memory per core. And these can get fairly high DRAM, upwards of 12 terabytes of DRAM. So if you think about where you would need a high memory server, it'd be things like a large in-memory database. You might think of SAP or HANA or Redis, some kind of big, heavy in-memory database, cache, or some form of in-memory analytics as well. Now, we next get to compute-optimized machines. And realistically speaking, these are designed to have better compute performance, compute-intensive workloads. These are usually on Intel scalable processors. Typically now they're probably on something different beyond that. They give you some really high performance computing. I didn't see any mention of AMD EPYC server processors at the time we talked about this, but understand they could probably be here now. And these types of compute optimized machines may change over time. And now let's talk about some of the memory optimized machine types. And these are shared core machine types. And here we're going to talk about focusing on cost efficiency by actually sharing physical cores. So in this case, we're talking about very kind of small things where we're trying to share a core between other things. So what you basically have here is the E2 micro and the E2 small and the E2 medium. So Echo 2 micro, Echo 2 small, Echo 2 medium if you use the phonetic alphabet like I do to avoid errors. And you've got two virtual CPUs for a little tiny period of time if you need it, like a little burst, like you need a little bit of compute performance for a couple of seconds, that kind of thing. But for most of the time, they're very small. So these are for running some little mini non-resource intensive workload, because it's often, for many applications, we need a lot of cores. And this is sharing a core with other stuff, so it's going to be really touch small. So let's talk about preemptible virtual machines. So what is a preemptible virtual machine? Now, this is going to be the lowest cost virtual machine we have access to in the Google Cloud. And it's designed for, things that don't require high availability, that can require starting and stopping at a moment's notice. So Imagine you had something that just needed a pool of servers to do a lot of compute calculations for a very short period of time. This is perfect for these preemptible machines. You have a batch job, you launch an infrastructure as code script, you open up 10,000 virtual machines, they do their compute for a couple of hours, and you close it all down, for example. And that way you're getting very low-cost compute. So a big batch job, and I may have exaggerated how big, and it might actually need to be that big. It's also for something that might be a non-critical. So you may have something that doesn't need to run continuously and it doesn't need an uptime guarantee. That would be a preemptible virtual machine. The key to remember here is these things can be terminated immediately on you at any time if someone chooses to bid higher than you. So bulk compute capacity, cheap when you need it, but you can't use it for anything too important. And understand they're not covered by any service level agreement. And by doing so, Google can offer these things very inexpensively too. Think about it. These systems can be shut down. You have no service level agreement. You can't offer any availability levels with those. So short-term, non-critical workloads. Let's talk about a shared shielded virtual machine. And a shielded virtual machine is a virtual machine designed to enhance your security by ensuring that the virtual machine images are actually what they're supposed to be. They've maintained their integrity and they don't have any kernel level malware or rootkits. So if you've got a sensitive workload, a shielded virtual machine can really help you here. And these are going to be ideal for sensitive workloads. They're going to be great for companies that need strict compliance requirements. And what it's going to do is it's going to do a secure boot. And it's going to ensure that the virtual machine boots up with only the trusted software. It's going to basically provide a virtual trusted platform module like you might have on a server or a workstation that's going to give you that hardware-based security function and ensure that virtual machine is the same as that it was last time or what it's supposed to be. So this gives us integrity monitoring of the system. It'll monitor the system and it'll detect us or alert if anything were to occur, like tampering. We also have the concept of confidential virtual machines. So this is really cool because it's actually keeping all the information encrypted the entire compute lifecycle. So normally speaking, you can have everything confidential, and then by the time you open it up in memory in the CPU, you unencrypt it. The CPU can do a thing, and then it gets re-encrypted again. So that's what we normally do. But what if you could keep it encrypted the entire time? Because while your system is in DRAM or processor, what if somebody else, a hacker, could get it and steal that data? That's always the concern. So in a really secure environment, you use confidential servers that actually have this kind of, they call it confidential computing. In this case, it's called confidential virtual machines. And this technology pretty much encrypts the entire compute process. So a lot more inherent security than traditional computing. And secured encrypted virtualization actually started with the AMD second generation processors. We're at the 5th generation right now. It sorts in-process encryption, so the CPU can natively handle the encryption and decryption of the data in memory without exposing it in plain text, which is really cool from a compute perspective, especially in a server that may have a lot of users on it from different companies. And so it gives us some protection from unauthorized access, even if a memory dump were to occur by a malicious actor, because again, it's encrypted. So use cases, highly sensitive workloads where data protection is really going to be critical, especially in industries with critical security and compliance needs. So let's talk about what a solo-tenant node is, so you completely understand it. So let me first show you what normally would be like in a cloud computing environment. So let's say you get a server in a cloud computing environment. And let's say this is the underlying physical server. Now you're going to note there's going to be virtual machines from a lot of customers on this server. So let's say this is a virtual machine, and let's say this is company's A's virtual machine. And on the same server, you have company B's. You also have company C's. And you also have company D's, which is true in many cases. and you may have company E. Now, depending upon the server and the kind of server, you could have a lot of different companies on this physical server. So some companies cannot handle that risk. Now, the reality is, let's call this, just let me show you what's going on here. So the reality is this is a pretty secure environment, normally speaking, because you can't go from this virtual machine to this virtual machine. It's blocked. You don't really have that access unless you've got IP connectivity to these two. And that would have to be set up in the hypervisor itself and the virtual networking. So generally speaking, one machine shouldn't ever be able to talk to another machine. The only way this can theoretically occur is it's called the virtual machine escape, which would be the concern that you could leave one virtual machine and then walk into another virtual machine and then get into another and steal another company's data. Now, pragmatically, it's near impossible because what you'd have to do is escape out of this virtual machine somehow, then attack the hypervisor, and then through the hypervisor, typically speaking, get into company B. So it is not a likely attack. But a solo-tenant node basically takes you out of the multi-tenancy where we have multiple companies, and it puts you into the environment where you're basically confirming that this server is mine and only my virtual machines will be sitting on that server. So that's a dedicated hardware for an organization to put their systems. So the target audience of solo-tenant nodes are obviously people that need high security computing. It's targeted towards those maybe in the public sector or those with highly sensitive workloads, secret formulas for new things, for example, or, a weapons manufacturer or a bank that's dealing with hundreds of millions of customers, people that need real security. Weapons manufacturer might need a different level. It would probably need a different level of security. But you can think of all the businesses that are out there. We could be having oil coming from plane A to plane B, and an attack on an oil could cause a problem. We could have dignitaries going from plane A to point B, and servers could be determining where people are actually going. We could have medical breakthroughs, and we can have pharmaceutical research, $1 billion new blockbuster drugs, which people don't want access to. So there's times in speaking when we really do need this level of security. So that's what this is really designed for, going back to try to get closer to that data center level isolation while still benefiting from the benefits of cloud computing. So that's what we're talking about, a single tenant host versus a multi-tenant host. Now, with a solo tenant host, we actually have hardware isolation because it's just our stuff running on our server. And this kind of isolation can prevent security breaches, potentially speaking. So security-sensitive workloads. Also, this might be good for performance-sensitive workloads, and here's the reason why. If we need a performance for sensitive workload, we need some understanding of the capacity and utilization of that server. Are all these virtual machines contending for the same virtual resources at the same time? Now, if we basically have control over that server, we can make sure that server is not oversubscribed, that the server has, for example, enough capacity. We have much more control. So high sensitivity, but also performance-oriented customers may be interested in this as well. Okay, we are back. Leo's back. I'm back for a few short moments to check and see if you have any questions. I know Leo's got a couple of things coming up that he's going to be showing you. Which you want to talk about real quick, Leo?
Yes, we have demonstrations on how to create virtual machines, with startup scripts, and how to create the basic infrastructure for a LAMP stack.
Oh, nice. The Linux, Apache, MySQL, PHP, in case you didn't know, which is a very common way that web applications are set up. So that sounds kind of fun, Leo. So were there any questions? Let me know you're awake. Give me a hashtag Google Professional Cloud Architect, or a hashtag I'm awake, or a hashtag it's Friday, or a hashtag I love cats, dogs, birds, or whatever your favorite animal is.
I think it's obvious I'm a little preferential to cats around here, although I had a parrot for many years and I love that bird and I love dogs too. So anything you want to know, we just want to hear from you. I want to know you're awake and you're having some fun, you're learning something. If you just got here, and you probably didn't, but if you just got here, it's a reminder that we have the first 4 days of this boot camp sitting on our YouTube channel. You can go back and watch the first 4 days. If you just got here, remember we've got a completely free study guide that's going to help you pass the Google Professional Cloud Architect exam. The study guide's about 550 pages. It's comprehensive. It's based upon the notes that I actually made for this course. So it'll help you prepare for that Google Professional Cloud Architect certification. So good. So I see one hashtag. Are you all awake? Let me know that you're there. And then I'll get back to the content. And actually, it'll be Leo's content, so it'll be extra fun to watch. All right, Chris, let's go back to the content.
Hello. In this lab, I will demonstrate how to create a virtual machine. I will start by visiting this address, cloud.google.com/compute/docs/overview. This is Google's documentation about the compute engine or virtual machine. We recommend you read the documentation to learn about the services you are going to use. Here on the left panel, I will select Compute Engine Instances. This page has a lot of explanation about the Compute Engine instances. Scrolling down to the bottom under the What's Next session, we can find a link to create a Linux instance in Compute Engine. I will click this link, and then it will present a guide for the steps needed to create the Linux virtual machine. It has some basic steps here, like selecting the project. In this case, I only have one project in this account, and I will go straight to the step number 2. Make sure that billing is enabled for your Google Cloud project. You can go to the project console, opening the left side menu and going to billing. And then if you see a message to enable billing, it's because billing is not enabled. If you see a screen like this means your billing is enabled or billing is enabled in this account. Going back to the steps, since billing is enabled, the step number 3 is to enable the Compute Engine API. I will go back to the console and select from APIs and services, enable APIs and services. Here I can click. If there were any APIs enabled, they would appear here on the bottom. As there are none, I will click the Enable APIs and Services button here. I will type compute. It will show the Compute Engine API. I click it. Here is the Compute Engine API. And now I click the Enable button. You can see that there are tutorials and documentation available for you to learn more. And we also have a documentation tab here. You can visit, read the documentation, and learn more about the virtual machines. The Compute Engine takes a while to be enabled, so I will accelerate. I will jump to the point where it is already enabled so we can continue from there. Now the compute engine is enabled. Let's go back to the documentation. And the next step would be the first step of creating the virtual machine. So in the Google Cloud Console, go to the Create an Instance page. Let's go back to the console, and from Compute Engine, I select VM Instances. And here I can see the Create Instance button, and also we see recommended documentation about this topic, about creating virtual machines. For each topic you select here on the left, you see different tutorials or guides appear on the right for you to follow and learn more about the Google Cloud. I will click the Create Instance button. Give the instance a name. And choose the region. You should choose the region that is closest to you. So in my case, I live in São Paulo, Brazil. That's the region I will select. And for the zone, regarding the availability zone, I will leave any selected by default. Here in the bottom, you see a table and also different kind of tabs or buttons here to select the different family flavors available for you to use. General purpose, compute optimized, memory optimized, storage optimized, GPUs. For this lab, I will just use general purpose virtual machine. And I will leave any tool selected because it's low cost day-to-day computing. Here you can change the specs of this E2 virtual machine you are trying to create. You can select a medium, a micro, or a small with different amounts of virtual CPUs and RAM memory. I will just leave the E2 medium selected. For each step, based on the configurations you choose, you can see the estimates, the monthly estimate charge for the virtual machine you are about to create. Here on the left side, I will click OS and storage because the default operating system is a Debian GNU Linux. I will change that for Ubuntu version 2404 long-term support, and I will accept the disk and the size for the disk. I will click select. I will not cover all the aspects of creating the virtual machine. You can do that. You can read the documentation and choose the most appropriate settings for your virtual machine. But most of the options you have, they are presented with a default value, and you can change that. But if you don't select anything different from the default will be applied to the virtual machine you are creating. Here, under the networking option, I will allow HTTP and HTTPS traffics just for following the guide here. And I will click Create Virtual Machine. So those are the steps needed to create a virtual machine as the first activity you do in a new Google Cloud project. Things like enabling the API or enabling billing on your account are things you do once on your account or on your project. You will not need to do that for every virtual machine you try to create. Here the virtual machine is being created. Yep, still. Now the virtual machine is ready. You can see by the green status. You can see some settings, including the internal IP address it was attached to, or that was attached to this virtual machine, and also an external IP address. By default, Google creates all virtual machines with internal and external IP addresses. Therefore, if you want to protect your virtual machine, you need to enable virtual firewall rules to avoid bad actors from the internet accessing your virtual machine. This is basically how you can create a virtual machine. Of course, there are other options you can set and use, but they will change according to the use case you will have for your virtual machines. In this lab, the idea was to demonstrate how to create the virtual machine, and now I will show under these three dots, you have different actions you can execute on our virtual machine. One of them is to stop or shut down the virtual machine. It will lose the external IP address, but the internal IP address, the disk, they remain available while the virtual machine is stopped. So you can start this virtual machine again with the same disk and same internal IP address. If you delete the virtual machine, it will completely delete all the resources that were created when you created the virtual machine. So if you are just learning and after creating this virtual machine, if you want to delete it right away, click the three dots and then click delete. You have other options like creating a group based on this virtual machine and view network details, create new machine image, different actions here. While the virtual machine is on, it is incurring charges. Even if you are in the free trial period, the credits will be consumed from the total, but you can stop the virtual machine when not using. The cost will be only on the disk and IP addresses only when the virtual machine is stopped. If you completely want to stop all charges or credit discount on your account, you should delete the virtual machine. Now, since you have the virtual machine, let's show how you can delete the virtual machine for the sake of this project, this lab. I will just click delete, and the virtual machine is now being deleted, and it will take some seconds for it to be completely removed from the account. Now the virtual machine is completely removed from your system. In this lab, I demonstrated how to create a virtual machine and how to delete a virtual machine you have no use anymore. Thank you for watching.
Hold on. Okay, sorry, we're back. We did a short lab there. We got a couple more short labs that are coming up real quick, but we just wanted to check in and see if anybody needed anything. We'll wait about 30 seconds to see if any questions popped up. If not, we'll roll with the new lab, and then if any questions pop up in there, Leo will be happy to answer them. So, Leo, which is the next one coming?
The next one is how to create the virtual machine and add a startup script. So when the virtual machine boots up, you can install applications, you can configure some services. So how to create a virtual machine with a startup script.
Okay. And what's the one after that, Leo?
After this one, we will have how to create a virtual machine and create the infrastructure for a LAMP stack.
Sounds great. Thank you. Chris, let's roll with the content.
Hello. In this lab, I will demonstrate how to create a virtual machine with a startup script to install applications. I will start here on the page cloud.google.com, and I will use the search bar and enter the term startup script. The first link is using startup scripts on Linux virtual machines. I will click to open this link. Here there is some considerations, some steps before you even begin creating the virtual machine. I will not follow these steps as they are in this guide, but I will do some adaptation. You can learn more by reading this page to learn how to use startup scripts during virtual machine creation. I will switch now to the Google Cloud Console. I'm already on the Compute Engine VM instances page. If you don't know how to reach this page, after you log in, use this top menu and go to Compute Engine and then VM instances. I will click Create Instance. And the first instance, I will create the traditional way using the console and checking the boxes and setting all configurations for this virtual machine. To simplify the steps for this demonstration, I will accept most defaults as they are suggested by the Google Cloud Console. I will go to the Networking tab and check to allow HTTP traffic, and then I will click Create. The only setting I changed was to allow HTTP traffic. All other settings for this virtual machine are the ones recommended by Google Console. The virtual machine is now ready. I will connect to the virtual machine using the SSH client provided by Google Cloud. I need to authorize the SSH connectivity. Now this prompt is from inside the Debian GNU Linux virtual machine. After installing an operating system, the first thing you need to do is to update the packages. So I will enter sudo apt update to update this operating system package. And then after that, I will install the Apache web server, issuing the command sudo apt install Apache 2. It's always recommended to visit the provider documentation, so you should go on the internet and check the Apache web server page to learn more about this web server. I will answer yes to the question if I want to continue with the installation. At this point, the installation of the Apache web server is finished. I can copy the external IP address of my virtual machine and then open a new tab here on the browser and enter http:// and then the external IP address of this virtual machine and it should show the default Apache web server page. And it says Apache 2 Debian default page. It works. Just to demonstrate how to customize the page, of course, this demonstration will not cover the whole development of a web page, but just to demonstrate how to customize this page, I will bring the SSH window back here, and I will list the contents of a directory on this virtual machine. In this directory var www.html, the only existing file is the index.html file. I will now replace the content of this index.html file, that is what is being displayed here on the web page, with a bare minimum HTML page just to demonstrate the customization options. I will bring the command I have outside in another application and paste here in the command line interface. This command is basically replacing the content of the index.html file with this HTML code. So it has a head in the title, and then it has a body with some text inside. Let's see. And I have got permission denied. I will then rename the index.html file to try to avoid this permission denied problem. Renaming files on Linux is like moving the content of the old file to a new file. So the command is mv as in move, and I will pass the directory the file is located. And the name of the file, which is index.html, and I will pass now the destination for the new file. And I'll add the extension BKP as in backup. So I'm moving the file index.html to the file index.backup. And I cannot move. I need to escalate privileges here to act as an administrator. And I will list the contents of that directory again. Now we only have the index.bkp. And to create the new index.html file, I will open a text editor that is nano, and I will pass the path and then the name of the file I want to edit. The index.html doesn't exist, so the nano text editor will create this file, and I can now enter the HTML code inside this file. I'll bring this code from the other application and right click to paste inside the file. Now I can use the Control Exit option to exit the file and say, yes, I want to save the modified buffer. I will hit enter to confirm the name of the file to write is the index.html file. If I list the content of that directory again, now we have the index backup and the index.html. Going back to the tab where I'm showing the content of that page, I will refresh the page, and then it says, hello world, this is the landing page of Linux startup script added directly. This was a manual process using the SSH window to install the Apache web server. Let's do this without the manual installation. I will exit this SSH window, and I will now create a new virtual machine, but now I will use the startup script. The same way as I did before, I will accept most defaults. I will go to the networking tab here, allow HTTP traffic, but now I will also go to the Advanced tab and use this automation field to enter my startup script. I will get the startup script from the other application here, and I will paste the startup script inside here. Try to increase the size of this window. Here it is. This is the startup script. It identifies that the script is a bash script. It runs the apt update to update the package of the operating system. It runs the apt install Apache 2. The -y here is to do a silent installation, meaning it will not ask if I want to confirm I want to install the application. And then the moving of the index HTML file into the index backup file, and then creating the content inside the index HTML file. With the startup script ready, I will click Create. Now the virtual machine is being created, and once the operating system is installed and the virtual machine is started, the startup script will be executed to update the system packages, to install the Apache web server, and then customize the index HTML file. The virtual machine finished creation. I will copy the external IP address here, open another tab, and enter http:// and the external IP address, and hit enter. It will take a while before the packages are updated and Apache is installed, and then the web page, the default web page, will be shown first, and then after the script updates the index HTML file, the customized page will be shown. Here is the default web page, and in some seconds the customized version will be ready. Here it is. Now I have two virtual machines. One was created using the manual process, or the Apache web server was installed using a manual process, and the second virtual machine, the Apache web server, was installed using a startup script. In this demonstration, I created the virtual machines and demonstrated how to use a startup script to automate the installation of applications in a new virtual machine just created. Thank you for watching, and see you in the next lab.
Look, we are back for a very, very short break just to check in with everyone. And then we'll get into the Leo one. You know, in production, on the next time we do this, that might be a good addition. So thank you for the suggestion. Definitely like that. So we'll go back to the new content. Let me know you're awake. If you just got here, maybe give us a like, subscribe if you're learning something, having a good time. And Chris, let's get back to the content. We'll see you soon.
Hello. In this lab, I will demonstrate how to deploy a LAMP stack. LAMP stands for Linux, Apache, MySQL, and PHP. This is a commonly used stack for web development. I will start by using the search functionality and entering the LAMP stack keyword. I will open the first link here. And I am presented the page, what is a lamp stack? If I scroll down here, there is a very interesting picture here describing the lamp stack. Here we have the Linux operating system as the basis for the lamp stack. We have the Apache web server. We have the MySQL database server. And then Google presents a free option for the programming language, PHP, Perl, or Python. We recommend you read this document to learn more about the lamp stack. To install the lamp stack, I will open another tab and I will search for Apache web server. I will right-click the first link, which is the httpd.apache.org. I will right-click to open in a new tab because I will search for MySQL. I will right-click the first link to open in a new tab. And I will also search for PHP. And I will open the first link, php.net. Switching to the Apache web server page. I am looking for an installation link or for a link for the installation page. Since there is no link or no direct link for the installation from the documentation section, I will click the version 2.4. That is probably the most updated version. And here from the reference manual section, there is a compiling and installing link, which I'll click to open the compiling and installing page for the Apache web server. Here are the commands for some operating systems like Fedora, CentOS, and Red Hat. And here are the commands for Ubuntu and Debian operating systems. Before I can run the commands, I need to have the virtual machine. So I will create a virtual machine right now. And I will name it the lamp stack. I will accept most of the defaults, but I will change the image for the operating system from Debian GNU Linux to Ubuntu. And I will choose the version as Ubuntu 24.04 LTS for the x86 platform. And then I click Select. And then I click Create. While the virtual machine is being created, I will open the VPC network firewall page. And I will switch to that page and show that for each project you create, a default VPC network will be created. You can delete this default VPC and create your custom VPC. But for this project, I will use the default VPC created. With the default VPC, some firewall rules are created as well. For instance, ICMP for ping, for testing the connectivity with the virtual machines. The internal default allow traffic. This is traffic going from virtual machines to virtual machines inside the same VPC. There is also a firewall rule to allow the RDP protocol and also for the SSH protocol. There is no firewall rule allowing HTTP traffic into the VPC or the virtual machines from this VPC. I will go back to the virtual machines page, and now the virtual machine is ready. I will click SSH to connect to the virtual machine. I will bring this window over here. And I will authorize the SSH connectivity. Now I have a prompt inside the virtual machine. Once you create a virtual machine, you should update the packages in the repository, so you always install the latest package. And from the Apache page, I will copy the command to install the Apache web server in the virtual machine. I will right click to paste the command here and hit enter to execute. It will ask for confirmation if I want to continue. I will hit the Y key in the keyboard and press enter to continue the installation. Once this command is executed, I can copy the other command, which is to start the Apache service. Right click, paste, hit enter to execute. Right now, the Apache web server should be already running. I will issue a command to verify the status of Apache 2. And the Apache web server is loaded, enabled, active, and running. Ideally, this now should be enough to allow me to open a new tab, enter the external IP address of this virtual machine, and get a response from the Apache web server. But as I demonstrated, there is no firewall rule allowing HTTP traffic into the VPC. For this reason, I will go to the firewall policies, click create firewall rule, enter a name, allow HTTP, and the network is the default network. The direction of the traffic is ingress or coming into the VPC, and the action on match is to allow the HTTP traffic. The source filter will be IPv4 ranges, and the range will be 0.0.0.0/0, meaning any IPv4 IP address can be able to reach the virtual machine. Here from the protocols and ports section, I will specify the TCP protocol with port 80, reminding everyone that HTTP on port 80 is not a secure protocol. For real-life use cases, prefer using the HTTPS protocol, which is secure, and the export is 443. After setting that, I can click Create to create the firewall rule, and I need to select all instances in the network. This rule will apply for all instances inside the VPC. This is not a secure procedure, There are other rules to make it more secure and restrict the HTTP protocol only to the virtual machines that will need to receive that protocol, and avoid creating rules for all instances inside the network. Once I set that, I can click Create. I am not using any security measures here because this is only a lab demonstration and I don't need to set that. But in a real life scenario, please make sure you take all security measures needed to protect the assets of your organization. Now we have the allow HTTP firewall rule, and I will go back to the virtual machine external IP address tab. And now the Apache web server default page is shown as a response to a request sent in the browser. I will go now to the MySQL web page, and from the documentation, I will search for the installation of MySQL. Here is the installation section, and I will choose the link for using the apt repository. Fresh installation, adding MySQL to the repository. I will not use that. Installing MySQL with apt. I will copy the command here and go back to the virtual machine SSH window. Right click, paste, hit enter to execute. Answer yes for confirmation that I want to continue the installation. Once the installation is finished, I will go back to the MySQL page again. And the next command is to check the status of the MySQL installation. Let's use that command to verify if everything is okay. And MySQL is loaded, enabled, active and running. And the last one is the PHP programming language. From the documentation, view online, I will click English to read the English manual. And for installation and configuration, I believe for Linux, I will use the installation of Linux using apt. I believe this is the best. I will use this one to install MySQL, to install PHP with MySQL and curl. I will merge the two commands. including PHP common and libapache and the command line interface as well in that same command. So apt install PHP MySQL, PHP curl, PHP common, libapache toolmod PHP, and PHP command line interface. Could not open the lock file frontend, permission denied. To correct that, I need to escalate the privileges. I will issue the command again and then add the sudo at the beginning of the command to overcome the limitation. It asks for confirmation. I answer yes, I want to continue the installation. While PHP is installing, I will go back to the tab requesting or receiving the response from the virtual machine, and the Apache default path is /var/www/html. And this file, or the file that is generated in this page, is an index.html file. After the installation of PHP, I will remove the original index.html file and create a customized index.html file with a bare minimum content just to show a hello world customized page. Let me go back to the SSH window. PHP ended installing, and I will list the content of that directory /var/www/html. And the content of that directory is the index.html file. I will move to rename a file in Linux is like moving the file to a new named file. Since I am in the home directory, I need to pass the full path for the file so I can execute the command on the file. So I want to move the index.html file, original file, to an index.backup file. If I list the content of the folder again, the content is only the index.bkp file. Now I will execute the nano, which is a text editor, to create a new index.html file in that directory. And the content which I will add here in this file is HTML. Every HTML file has a header. Hitting tab, I will enter 2 spaces. And every HTML tag needs to be opened and closed. Here is the opening header. Here is the closing header. And in between both tags, I will enter, which is a title for my HTML page. It will show my lamp stack. After the header comes the body of the HTML file with the corresponding closing tag. And inside the body, I will use in H1 tag with the text hello world. And I will follow by a paragraph line with this is the landing page of my lamp stack. And this is it. I need to close the HTML tag. And that's it for the minimum HTML file. I will hit Ctrl X to exit the editor. It will ask if I want to save the modify buffer. I answer yes. And it will ask if the file name to write is /var/www/html/index.html. I will press enter to confirm the file to be saved. And I will check the content of that path again. And now we have the index.bkp and the index.html. If I go back to the tab receiving the response from the web page, note that this title will change and the content of the page will also change when the web server sends me the new customized index.html file. Now it shows my lamp stack, and here, hello world. This is the landing page of my lamp stack. The objective of this lab is to demonstrate how to deploy, how to install the applications needed to use a lamp stack to create web pages. I will not demonstrate a full programming or creation of a web page using the MySQL database, using the PHP programming language. Now, for the cleanup, I will bring the SSH window back, and I will enter exit to terminate the SSH connection. And from my virtual machine, I can select it and hit delete to delete the virtual machine. I will click delete to confirm I want to delete the virtual machine. While the virtual machine is being deleted, I can go to the firewall page, select the allow HTTP route, and click delete as well. I need to press to click delete button to confirm I want to delete the firewall rule. Now the firewall rule was deleted. The virtual machine is still being deleted, but the trying to reach the external IP address from the browser tab should not work anymore. The browser is trying, but not receiving any replies from the web server. Now the virtual machine is deleted. In this lab, I demonstrated how to deploy a LAMP stack, a stack using Linux, Apache web server, MySQL database, and the PHP programming language. I showed how to access the web server from a browser, receiving the default web page at first, and then customizing the index.html file to show a customized version on the browser. After everything, I cleaned up, I deleted the virtual machine, and also I deleted the firewall rule allowing HTTP traffic into the VPC. Thank you for watching and see you in the next lab.
Welcome back. We are here. We've got one more video to go today, a technical video, and then a lecture on more on the compute side. And then other than that, we will begin again next Monday, where we have almost a full fun-free week of training for the Google Professional Cloud Architect exam. So we're going to get into another video. If there are any quick questions here, let us know. And if they're not, Leo and I will go back with the next video of the content and see how we do. We're trying to go through this and make sure that we've answered all your questions, make sure everybody's getting a good experience. Leo, thank you for demoing that for everyone. And do you want to talk about some of the labs you have next week going on?
Sure. For next week, we have creating instance templates, manage instance groups. We have how to create a managed instance group from an existing virtual machine. So we have a lot of compute stuff to demonstrate for next week as well.
Okay, fantastic. And I look forward to that. As a reminder, we have a guide to help you pass this. If you just joined and just got notified by YouTube and just walked into this free Professional Cloud Architect Bootcamp, don't worry, you can go back and watch the previous 4 days. We also have a study guide, an extensive study guide to help you prepare for that Google Professional Cloud Architect exam. So click the link, sign up, and then you will get it. And then next week, like every week, we will run a webinar on how to become a cloud architect. Now, if you want to learn about a security architect, AI architect, enterprise architect, network architect, we've been doing this stuff forever, and we're happy to guide you in any of these roles. But we'll talk about the role, what we do, the skills you need, how to bypass HR when you're not hired, how to show that you're ready, how to create the right kind of portfolio, what hiring manager is looking for, and all of it. It's free, and then we'll answer any questions you have. So sign up. It is completely free. So I didn't see any other questions, which is pretty good. So maybe give me a hashtag Google Professional Cloud Architect. We'll have one more video, and then this will be the last one for the day, and then we'll finish the first week's. Congratulations, and then we'll be at the second week's next week. Chris, let's roll with this content.
So now we're going to talk about images and what virtual machine type images actually are in cloud computing. So I first want to describe it so you understand what an image is, and then we'll talk about the types of images. So normally speaking, you may have a hard drive, and if you look at the root of your hard drive, at Windows, it might be C:, or if you're on a Linux machine, it's /root. What you'll note you have is a whole lot of stuff underneath it. So you might have root, and then underneath that you may have users, for example, and then we may have say Cindy as a user, and then Cindy may have her home directory, and then Cindy has her photos because she likes to take photos. Cindy photos, and then underneath the photos will be the folders. So that's what a normal hard drive would look like, for example. So what an image is where we take all of this, every single file, everything is copied bit by bit in an exact copy to this little single file called an image. And the key is, the key is this image, we'll call it a VM image. This virtual machine image can now be taken to any virtualization server on the world. So if I have this physical server, for example, and the image is running on this server, but I want to move it to another server, all I have to do is basically take an image and move it. And that's what we're going to see. And that's how easy it would really be as I take my image with me and where I want to go. So the cloud makes it a lot easier for you. So let's say in a hardware environment, we created a virtual machine. The first thing we needed to do when that virtual machine was install an operating system. And then we'd have to install any of the drivers that were necessary, if it were necessary. And then after that, we can install our necessary applications, right? Well, with an image, we can pretty much get pre-made, where all you have to do is click a button, an entire virtual machine where its operating system is going to fully come up for us. And we can go and get an image, for example, that's got the operating system and the application's already stored for us. So it takes out all the heavy work we used to do in the data center when we had to manually install these things. By the way, we can use virtual machine images in any virtualization data center, and that's why most servers have been using server virtualization for decades now, because that ability to just move and create an image seriously reduces overhead. So we'll have lots of images available on the Google Cloud platform. Images will be available for a wide variety of operating systems, things like Debian or Red Hat Enterprise Linux or Windows Server. Or you may have an image that's already optimized with, say, Microsoft SQL Server even installed. Or you'll be able to get images that have firewall software, typically from a marketplace. So all kinds of cool images. And these are typically designed when you get them that are already hardened, that are usually secure and ready for you to go. So keep that in your mind. And some of them can be automatically receive security updates and other updates to keep these images running well. So in my mind, that's one of the advantages of any kind of competing or virtualization. So how do we get these images? Well, we can create a custom image. A custom image we could create, say, the golden image, which from a policy perspective, we want all virtual machines to use this operating system, all these patches, all this endpoint protection. So we create a golden image, and then anytime a new virtual machine is launched, it follows that image, and now we have less configuration drift in our images, in our virtual machines that are out there. It reduces time. So we can create custom images with custom software, all of our services there, and our configuration is already optimized. We can create that image, and then someone with an infrastructure as code script could launch 10,000 if they wanted in minutes. So that's the key benefit of cloud computing. That speed and agility is just incredible. It's worth extra costs in many cases. So, we have to determine who can manage the image. So we're going to need some degree of access control on the images, because we don't want the wrong people getting access to the images and being able to dissect what our environment looks like. We need to determine who can deploy it. So we need to control the authorization of who's allowed to deploy an image. We need to store our images, typically speaking, in an image repository, which is a secure environment that is secured where their images are going to be. Some people call it an image factory as well. And we need to validate these images and make sure they haven't changed. Make sure that they're still good. And if we notice a weakness, maybe we need to remediate that image and create a new one that we use for the future. And now let's talk about the kinds of images that are available. We can get public images. And this is going to be an image that's made for us, made for the public in general. You just start it, it reduces the time and necessary for the setup. This is going to give you a secured virtual machine. So all in all, there may be a whole bunch of options that you can choose just to click from Google that'll be available to the public. That's easy. We can also make custom images tailored to the needs of our organization. And this helps us create a more secure, we can remove packages that we don't need, and we can also optimize to any level of security we want if we have the sophistication to do it. And that's the key. Do we have the sophistication to harden these systems? We can determine only the minimal services we want and nothing else, which could be used for an attack factor. So if we've got the right people, custom images can be great. They will offer us better control and compliance of our virtual machines. Now let's look at instance templates so that we can create something called an instance template, which is going to define a machine type, a boot disk image. It'll include some labels and other properties for the virtual machine. It's used for creating virtual machines from pre-existing configurations quickly and consistently. So we have an instance, we make a template, and then it becomes so easy to create new versions of that same thing in the future. That's what we're really talking about. So when we talk about instant templates, it's really going to ensure consistency across multiple deployments, across multiple virtual machines. From a security perspective and a management perspective, we don't want what we call configuration drift. and Mike sets it up this way, Sally sets it up this way, Billy Bob sets it up this way, and Tony sets it up this way. We don't want that. We also want to do things in an efficient manner. People cost money, so if we can do things efficiently, but a pre-made image or a pre-made instance makes life really easy. Think about that. Infrastructure as code. We've got pre-made instances, and one infrastructure as code script could launch 10,000 virtual machines. So we have that agility from some of these DevOps practices, some of this infrastructure as code, and then we've got the efficiency of good images. Things are starting to become a lot more efficient. There's much less like things to go wrong. Access control. We can determine where these images are so that only the right people can launch these and make the systems look the way they're supposed to be. And then we can monitor for differences in our configurations. Find configuration drift, find misconfigurations that will open us up to security vulnerabilities. So instant templates really are going to make sense here. And we can also think about that. Now let's talk about instance groups. So what are managed instant groups? Now that's going to be a collection of multiple virtual machines that you can manage as a single entity. So I want to say that again to make sure it makes sense. It's a collection of virtual machines that you can manage as a single entity. Think about this. Let's say you had a whole bunch of these little servers or virtual machines, and then you put them all in this group. And then all you have to do is manage the group. Okay. Remember when we talked about role-based access control, where when Cindy got hired, Cindy was put into the managers group? And then Cindy got all the permissions of the manager, all the systems she could access. Well, and there was like various servers. There was like a performance management server she had access to, and an expense report system, if you'll recall, expense reports. And we hired a manager. All managers get the same managers groups and managers permissions, and then they all get access to these applications. It's fairly similar in concept, and we're using to the same thing. We can manage a lot of virtual machines by creating a management group and then just adding their virtual machines to the group. And it makes it so easy to manage a large number. And again, it all goes back to efficiency. We're always looking for efficiency. So when we create a managed group, we can add auto-scaling, which is going to add capacity when needed, and it'll shut those extra machines off when not. We can enable auto-healing based on a health check. So I can say we need 3 virtual machines, and one of the virtual machines doesn't respond to a health check, so the load balancer stops sending traffic to it, and we add another virtual machine. All of a sudden, we're still up and operational. We can use these instant groups to deploy against multiple data centers or regions or entire global enterprise if we wanted. You can automatically update these images across without downtime. So we've got a whole lot of great things to use these instant groups. It's already got load balancing to load balance between your virtual machines. So that's called the managed instant group. We also have this concept of an unmanaged instant group, which is going to be a collection of virtual machine instances that you would manage individually. That's why we want to create this managed instant group. So we have to think about what we would use and where we would want to use it. So let's talk about managed instant group considerations. We have to make sure that we have a good configuration, because we need to make sure that our configuration is good, because incorrect updates, for example, could trigger endless creations of instances if a health check were to go down. So we need to make sure that the systems are really designed intelligently. So if a health check goes down, we don't just keep creating virtual machines because something else is broken. Imagine the cost of that. These managed instance groups are designed to assist with scalability and availability, which they can, assuming the compute is the limitation. If some other limitation is your problem, then just the virtual machines won't be enough. These managed instance groups are going to be great for workloads that are going to need high availability, because you can make sure that it self-heals and you have enough servers that are actually running, auto-scaling and auto-healing. So this is one of the benefits of cloud computing, is the concept of these kind of easy management, and at the same time add capacity. So when we talk about auto scaling and we talk about the kinds of scaling, let's talk about what the types of scaling. We generally speaking have vertical scaling, which is this. We add capacity. So we're on a server and we need bigger capacity. The server has 64 cores and 2 terabytes of RAM, and that's pretty much evenly utilized and heavily utilized. We go up to 128 cores and 2 terabytes of RAM, DRAM. That is vertical computing or vertical scaling. But guess what? What happens when that one big server fails? You got nothing. So horizontal scaling would say, well, if the 64 core server is not enough, add a second 64 core, or let's start with 32 core servers, and let's normally run 2 32 core servers and add extra when we come out. So that's horizontal scaling. And because the cloud, we can add capacity horizontally and then come in horizontally, it often makes sense. Now, we also have add more web servers, for example. But we also have to think about predictive versus reactive scaling. What if we can use AI to predict when we're going to need more capacity based upon what's going on and add the capacity ahead of time and then shut it down? Versus reactive scaling, which is typically what we use in cloud computing, is CPU hits 85%, add a new server. And the problem with reactive scaling is it's not often fast enough. So the problem is auto scaling can take 10 minutes, 15 minutes, 20 minutes, depending upon how many things you need to scale out to reach maximum capacity that you need to. But it's usually a little slow. So imagine a company that was a global retailer that all of a sudden needs to send an email to 300 million users of theirs about a sale. Now that could take their computers, and as soon as that email goes out, it could come in with such a vengeance that it almost overwhelms their servers. And with predictive scaling, that could be predicted ahead of time. With reactive scaling, what's going to happen is so many things are going to hit that server. Some people for about 5 or 10 minutes are going to get bad performance until enough server capacity gets there, and some others might be lost. So what businesses typically do is they plan it ahead of time, and they intentionally scale when they know what's going to happen before it occurs. But what if AI could do it for you more dynamically? And that's going to be predictive scaling. And if we really think about how great this auto scaling concept is, and it's one of the biggest benefits of any kind of cloud computing, so let's just look at this. Imagine we had a global retailer's site. And for example, for this website, they really only need, let's say, 2 web servers. And these 2 web servers, they're typically running at 40% each at all times. Let's say this is a load balancer. So if these 2 web servers are normally running at 40% each, and that's everything is fine, even if one of these servers fails, the other server will only be at 80%. Just for argument's sake, let's just keep it there for 1 second. Now, this might be normal. This might be the normal utilization of this website. Now, and this is all times throughout the year, except for the holiday season. So let's say in the holiday season, instead of needing 2 of these servers, we need 10 of them. So the way this would normally work in the data center, and obviously this would be multiple data load balancers, what we would have to do is we would have to run 10 all year long to make sure that when we had the big spikes in traffic, we didn't lose orders. And unless we use a cloud, and a private cloud can give us capacity too, we had to pre-build all this stuff out, which meant 90% of the time we were paying the electric, we were paying the fees, we were managing 8 additional servers when we only needed 2. So what the auto scaling really enables is everything is great. These 2 servers are happy. And now all of a sudden we have that big holiday season or that big sale or whatever is biggest for this business. And now all of a sudden we need extra servers. They're adding, they're coming up. And now we've got the same 10 servers. So that's one of the key benefits behind cloud computing is that auto scaling. And that auto scaling works for containers. That auto scaling works for virtual machines. So where do we store our environment? Well, if we're dealing with virtual machine storage, virtual machines store their information in block storage and cloud computing. We can't use the storage in the virtual machine, generally speaking, in the server itself, because what happens if we delete or terminate that instance in most cloud providers, it goes away. So when we have a virtual machine in a cloud computing environment, and we talked about this, or we'll talk about this more, but I know we've already talked about it, but we have our virtual machine, and the virtual machine's hard drive is block storage. Now, we may back up that a virtual machine to object storage. And if we needed 10 servers to share the information at the same time, we would do file storage. But it's always going to be block storage on the cloud. And it's always going to be block storage. So keep that in the back of your mind. So this is what all virtual machines will look like in all cloud computing. If you'll recall that in this particular environment, we've got storage servers that are sitting in here somewhere. And they're connected to the network. These virtual machines are connected to the network, and that's how they use this virtual hard drive that's stored on the storage servers. Now, if this is AWS, they call it elastic block storage. If it's Azure, they call it managed disks. But the marketing people at Google decided to call them persistent disks. So when we talk about block storage in Google, we'll be calling them persistent. And when it comes to storage that's network storage, block storage is going to be the fastest we can get. Please understand that block storage is nowhere close to as fast as the server storage that we're typically dealing with, which means if we're on server storage, we may need to get creative in the cloud to get the similar performance if we needed server level storage, but it's not usually that much of a problem. So we're going to have two kinds of block storage. We're going to have something called zone persistent disks. And those virtual disks or those virtual hard drives or those block storage environments are going to be attached to instances or virtual machines in a single zone, a single data center. This is going to give us very good performance and very good reliability for the workloads in that one zone. We also have the concept of a regional persistent disk. And what that's going to do is it's going to replicate this data across two data centers. And that way, we've got higher availability of our data because our data is redundant to two different data centers, and we could always get it from a different data center than the one we're actually in. So zone persistent disks, we can get them as, in a single zone or a single data center or across data centers, the regional persistent disk. When it comes to storage option, generally we have the local SSD. And that is going to be the local drive in the system. It'll typically be NVMe type storage at this point. Now, keep this in mind. This is the highest performance you're going to get. We're to the point where, there's a 19 million IOPS RAID card that you can put in a server itself, and block storage is nothing close to that. So if you have a workload that needs extraordinarily high IOPS, input and output operations per second, which means super low latency, this is the best thing to do. But here's the problem with cloud computing, that the data on this drive, on this virtual drive, is what's called ephemeral. So it is not long-term storage. If you stop that virtual machine, there goes that virtual hard drive. So you must use block storage if you need to be able to save your information after the virtual machine is gone. Let's talk about cloud storage budgets and buckets. And what are they? Object storage. And they, realistically speaking, require cloud storage fused to be configured within the virtual machine's operating system. And what it does is it mounts the cloud storage bucket as the file system. No, virtual machines don't use object storage. So for this to occur, there's a type of a gateway. There's a translation between object storage to make it feel like a block storage hard drive. So this could be used to store large amounts of information, large amounts of unstructured data, backups, and media files. So this is typically where, object storage, where you typically would upload your data, copy your virtual machine images. If for some reason you were looking for a cheaper form of storage, it uses some object storage to a degree, and there's some kind of translation to make it feel like block storage. Typically some form of a storage gateway. And not like an AWS storage gateway, but a gateway is when you translate one media to another media, that type of a gateway. Now, Google also has something called file store. And what is it? File storage. So if you had a Linux machine and you created an NFS share on it, the network file system share, that is file storage. On Windows machines, if you shared a folder and created a server message block share, that is file storage. And guess what? On a Linux machine, if you decided to set up a Samba share or a server message block share on a Linux machine, that is still file storage for Windows systems. So we can attach file storage to multiple instances, which means we can put the information in one place, and 50 servers could use the same information with file storage, and that's where we would typically use it. So file store is basically NFS for with Google's marketing name on it. It's going to operate just like NFS. So I want to make sure you understand those. File storage in cloud computing is used when we need it in multiple environments. So let's say this is the file storage. And let's say we had a whole bunch of servers that needed access to the same data. Let's say servers. Let's create some servers. And they all needed to access the same information at the same time. This is where we use file storage. So block storage, storage for a single server. File storage, serving information to multiple servers. File store is NFS-like, and it is POSIX compatible. Now, let's talk about the OS login. So the OS login is going to simplify SSH access management by linking SSH users in Linux to the respective Google identities and cloud identity. And it's going to centralize the SSH management using Google Cloud IAM to help with some of the management of using SSH to manage so many machines. With OS login, we've got the benefit of centralized account management. It's going to manage the full life cycle of Linux accounts through Google identities, and it's going to be similar to single sign-on for SSH access. It's going to simplify permissions management because it's going to integrate with Cloud IAM. We've got the benefit of automatic updates and automatic permission updates to make it a lot easier to really manage SSH keys. We can import existing accounts, and we can import these accounts, these Linux accounts from either on-premise Active Directory or an LDAP type servers, so we can synchronize across our environments. With regards to OS logins, it can help enforce security because an organization's policy can be enabled to enforce the OS login, preventing unauthorized users without those proper Google identity credentials from even accessing a virtual machine via SSH. It's going to help simplify key management. It's going to get rid of the complexity and the risks of manually provisioning and managing SSH keys because they're going to have to manage these keys, especially for privileged users. And if we think about a use case, it's going to be ideal for organizations that really want to manage SSH centrally, especially those kind of organizations that are going to, with existing cloud identity infrastructure, or people that are migrating from their off-premise environment and using a different directory, like one of the Google directories. Okay, we talked about virtual machines. Now let's talk about Google App Engine. And Google App Engine is a platform as a service environment from Google Cloud, which is going to provide a fully managed serverless application. So what does this mean? It means developers can create their code and they can deploy their code directly to the Google Cloud without thinking about the underlying infrastructure. This is called application virtualization. That's all it is. All cloud providers do it. It should sound a whole lot like Elastic Beanstalk with AWS. And it supports, the majority of those coding languages, the usual suspects that all other providers are working with. Now, what's the key? What are the benefits of using Google App Engine? Well, there's nothing to manage, so the developers can focus on building their code and building their applications. They don't need to think about the server. They're not thinking a lot about networking or heavy-duty networking here. Google is managing the platform. They're managing the scaling in and out when it needs, the patching, the monitoring, and it really enables developers to focus on code. And it means you need less teams, less networking people, less security people. You still need them, but you need less of them. Google App Engine tends to scale up and down on demand. It offers built-in memcache service to minimize any kind of database queries and improve performance. So there's a lot that you get with this, but you lose a lot of control with this. So is giving up the control worth it? It depends upon the organization. Some good uses of Google App Engine would be for development teams wanting to build applications and deploy them quickly and not have to manage them. Organizations that don't have a lot of infrastructure people that understand infrastructure well, this could be great for. And, it can make it fairly easy to deploy things and have version control. Applications that are comprised of one or more services often need different runtime configuration and performance settings. We can, deploy lots of things. We just write the code and it's just going to run. So it's so much easier. Different versions of code, different environments is needed. So traffic can be routed to various versions as needed. So you've got some good control over deployments. You might have a current deployment, push it to a new version, maybe 10% of the traffic, see how it worked. If you like it, transfer everybody over to the new version. Now, there's some problems with Google App Engine too. Well, it's proprietary, so this is going to potentially give you some vendor lock-in problems, which could be big. And, in a world where 98% of organizations are multi-cloud, do we want to deal with these vendor lock-in challenges? Possibly not. So it depends what it's there and who's going to use it. It was initially this was a very initially popular, and a lot of organizations really loved this kind of a balance. Especially initially with cloud computing, just create your code and it runs. But sometimes organizations need something where they've got a little more performance or control. And other times this concept of reduced operations could be highly beneficial. So it's all about knowing the organization and what they're trying to achieve. So let's talk about App Engine Flex versus App Engine Standard. App Engine Standard is a sandbox environment with you can basically run supported programming languages. It is rapidly scaling. It's great for applications that are going to experience sudden spikes in traffic and need that kind of rapid scaling. And it's somewhat cost efficient. You have to pay for what you use when you need it. The applications can scale to 0 when there's no traffic, which is going to cut your cost, and then scale out when you need it. So, the App Engine Standard environment is going to be great for applications that they're used with supported programming language in the standard environment. So there's going to be a lot of use for that. Now let's discuss App Engine Flexible environment. And this is a little different. It's much more enhanced. In this case, the instances are going to run within Docker containers on Google Compute Engine virtual machines. So you're going to have a lot more flexibility here. Now, App Engine Flexible environment is designed for consistent traffic with gradual scaling. It allows for custom run times and things that would not be supported with regards to App Engine Standard. We have different programming languages here. We get more versatility here. We've got more intelligent traffic routing from cloud to cloud, for example, or cloud to data center with App Engine Flexible environment. So it's going to be much more robust for the kind of things that we deal with in many cases. So when should you use each? You would use App Engine Standard when your application runs on a supported runtime, when you need rapid autoscaling to handle sudden traffic spikes, and you're looking for a cost-efficient model that'll scale down to 0 when it's not in use. When to use App Engine Flexible? Well, when you need custom runtimes, or you need to use an unsupported language, when your application has steady traffic or requires gradual scaling, when you need to integrate more closely with the Google Cloud environment or route traffic more intelligently to other cloud providers because you have a multi-cloud architecture. So that's typically when you would use each.
And we are back. Reminding everyone that next week we have more labs. We have labs on creating a custom image, creating instance templates, creating managed instance groups, and we have block storage, object storage as well, creating object storage buckets.
Yeah.
And we will have some pub sub as well next week.
Fantastic. I love it. I think there is one question which I'll answer briefly, and then we can all have an absolute wonderful weekend and have more fun time next week. Rohit, can I give a path for learning to become a cloud architect? Yes, I will give you a document and invite you to a webinar. And is it required to follow a path like a CCNA before joining a cloud program, or start by training for the job you want, the cloud architect program? So here's what it takes to get hired. First, Chris, please drop a link to the How to Become a Cloud Architect ebook so Rohit can download it. Rohit, please come to my How to Become an Architect next week. We can talk. I'll go over the entire role, tell you everything you need to know, and we can ask questions live. Chris will drop that in. But what does it really take to be a cloud architect and get hired? It's not your experience. You have to have the top 25% of your skills out there, meaning you should be in the top 25% of all the cloud architects based upon your training. If you're with us, you will be, because you will stay with us until you're hired, and you have about 1,000 hours of training where everybody else does about 100 or 200. That's why you'll be in the top 25%. You also have to have the right skills, and at least 3/4 of the skills for the architect are actually business skills, not tech skills. But you have to have the business skills and the tech skills. You have to build a real architecture portfolio. Now, that are things that architects actually do. Architectural artifacts, RFP responses, reference type architectures, those types of things that are going to show you as an architect. After you're able to do the job, that's when you do your certifications, because there's people that I've gotten hired, like Jeffrey, who got hired at Kalian, and he never had any certifications, and he never worked in tech in his life, and it was his first tech job. Or Delroy, who got hired by CDW as a security architect without a single certification. So first we train you for skills, because you're hireable with skills, but you won't know anything out of a certification. After we teach you the skills, then you get the certifications. Then we teach you how to optimize your resume. Then you need to, and if you're with us, we'll teach you. But if not, you need to learn how to tune your LinkedIn profile, how to create the right content that gets hits, how to make managers come to you, and how to clean up your social media, because most people have content on their social media that I would look at as a hiring manager and say, I can't hire this person. So you need to know how to remove that. Then you need to know how to go straight to the hiring manager so you don't get blocked by off. And then you need to know how to interview, win the interview, and negotiate a higher salary. Now, we teach all that. Now, what is it, the skills that you need? And why will you not get them out of the CCNA? Well, you need to understand networking. So if you take the CCNA, and I like the CCNA, it is in my list of certifications. The CCA is about systems administration. What is systems administration? How do I configure something? How do I configure it? Now, the reality is, as an architect, you don't configure anything. So what I would tell you is this book, TCP/IP Illustrated, even if it's just volume 1. Now, this will teach you everything you need to understand about the Internet Protocol. For example, if you understand what the Internet Protocol header looks like, then you understand how you could interact with a firewall. You understand how you could traffic shape and traffic police a certain level of traffic, how you could take a certain level of traffic and prioritize it so that it gets through if a worm or a virus are there. You can do all kinds of things if you understand IP. But you won't learn that in the CCNA. You'll learn how to type config T, interface gigabit Ethernet 0/0. You'll learn how to put an IP address on it in no shot. So the CCNA is about systems administration. And the best way I can describe it is, here's what you learn in the CCNA as it pertains to the routing protocol OSPF, how to configure it. So you will learn config T, router OSPF1, for example. You learn how to add a network statement 10.0.0.0, and where you put it in which area. And that's pretty much it. Now, when I interview an architect, Rohit, I say, okay, now I see you put down that you've worked with OSPF. Yes, I've configured OSPF before, like in the CCNA. And I say, great. Could you tell me the type of LSAs that exist in the various areas? and what a type 1 LSA does, what a type 2 LSA does, what a type 3 LSA does, a type 4, a type 5, a type 7, a type 10. And they won't know. So you have to learn networking, but you actually have to learn BGP, which is not covered in the CCNA. You have to understand IP address planning, which we teach you, which is not covered in the CCNA. You have to understand routing architectures, which is not covered in the CCNA. So here's why I want you to do this. I want you to learn the skill. And the best way I can describe it is the certifications will be so silly easy if you have all the skills and have all the knowledge. But if you don't have the knowledge, the certifications will be hard. So Rohit, if we looked at your life, if we look at a cloud architect that on average earns $20,000 a month, if you spend 3 months to pass a CCNA, and then all of a sudden we have to start you from training from zero, it's going to take you another 9 months to train you. But what if we trained you and in 9 months you could just take the CCNA with a week's practice and pass it and be hired by the time you're done getting the certification? So the reason I like this book, and I've mentioned this book twice. So I guess it was about 4 years ago. Now I've been designing cloud providers for decades. I've been designing clouds for decades. There's not a single thing that I didn't know in cloud computing or data center computing. But you know what I never touched, Rohit? I never touched the Google Cloud. So I bought this great book from Cybex. This Cybex book was basically a Google Cloud vocabulary book. It told me all the Google services and exactly what they were in real world. So then I took my 20 years of knowledge and took the exam 2 days later. The reason I could pass that exam in 2 days is because I knew cloud computing. I knew everything about cloud computing. I knew how to design it, how every system worked. It was just learning Google names. So if you're with us, you're going to have top 25% networking skills and top 25% security skills and top 25% compute skills. And you're going to have all the business skills you need, which will include things like sales skills, communication skills, presentation skills, writing skills, leadership skills, executive presence, the business knowledge you need to drive for transformation. But you'll also have those networking skills, whether they be BGP, IP address planning, switching, when to use NAT, how to select the right kind of wide area networking technology. In the CCNA, they'll teach you how to configure it, but you won't know whether to choose a software-defined WAN or a SASE WAN or an IPsec tunnel or a private line. But when you're done with us in architecture, you'll know that. So understand the CCNA is great. Understand the purpose of certifications are to get an interview. The purpose of developing your skills is to get hired. You can't get hired with the skills, but you can get hired without the certification. So that's why we say certifications last. Train the skills for the job. Be in the top 25%. Build all the skills that are absolutely necessary. Then build your portfolio, because now you're hireable. Then after you're hireable, you worry about brand building things like certifications, which get you an interview but not hired. But you'll get hired from your content that you learn. Then optimize your resume. Then optimize your LinkedIn profile. And then go to the hiring manager and prove to them you win. That's how you do it. And no, you don't need any other tech jobs. Noah's first job was the last job was a social worker, and he became a cloud architect. Vladimir was a 24-year-old in college, first job as a cloud architect. Wallace's first job at JP Morgan Chase was an enterprise architect. Pierre's last job was on a sailboat as a sailboat operator. He was in his 20s, but he's now working at LeaseWeb as a solutions architect. Debbie was doing something outside of tech, but got hired at Credera as a solutions architect. Jermaine was working in landscaping. It doesn't matter. Get the skills. You'll have any job you want. That's the way I train people, and that's the way I recommend you learn. And I'd love to see you in that webinar. And please download that document, because it'll list every last skill you need. And I want you to be prepared, because I want you to get these great cloud architect jobs, best jobs in the world. All right. Sorry about that. There was a career thing, and we know how I love careers because I like tech careers, and I've been an architect forever. And it's architecture and internal medicine. They're probably the only two things that I know, and they're the two things that I love most. So, Leo, you got all kinds of cool stuff for everybody next week to share. I've got some geekiness, academia, the underlying concepts, and as they pertain to architecture. So we are very excited to see you next week. So maybe give us a like, maybe tell some friends, please watch this over the weekend. Maybe rewatch the last 12 hours over the weekend. Be a top 25% professional, because they're always there. The top 25% is always getting hired. The top 25% never gets laid off. And the top 25% can't be replaced by AI. So have a great weekend, learn a little bit, and I can't wait to see you all next week.